3, 2, 1, game screen. Hopefully it goes.
Hey.
Oh, okay. I think I unmuted myself like a bit too early, and I think I was like, I was talking about like starting the stream, going to game stream like on the stream, but like whatever. We love Scuff here. We love Scuff.
Yeah. I was like, I do have your stream open on the side, and I started hearing your voice double, and I was like, hey, that's what starting same screen.
Yes. But yeah, anyways, okay, this is probably the weirdest stream idea I had. How did we get this idea again?
Yeah, the thing is, I do remember. So, I was streaming, and you jumped on my chat saying something about maths and talking about a math problem, and we were like, hey, that's not a bad idea for stream. And here we are.
Oh yeah, no, I think I can remember now. Like I think I was like, I think I was doing whatchamacallit again. I was doing my homework while watching your stream, and then like I think you actually asked what I was doing, and I told you I was doing like I think I am not entirely sure, but like if I recall correctly, I was doing like interpolation, and then you asked how do we do it, and then I gave like an entire paragraph.
I forgot.
Oh, that is confusing.
But interpolation just like sent me back to that moment, and trying to understand what you sent in chat.
It is so confusing. Yeah, don't worry. I also was confused by that. Also, reading chat, welcome to your boy. Frost is here? No, Frost is not here. Frost is dead or something. I don't know. Sorry about that. For context, yesterday I was streaming, and like there's this one person named Frost who never joined.
Oh.
Yeah.
Oh no.
But yeah, like essentially, like if you don't know, interpolation is essentially like I can just like give a short, tiny explanation. So let's say hold on, can I get like a tiny brush size? Let me see. Okay, there you go. Like let's say there's like you have a graph, right? Like this. Oh, that's a very smooth line. Like let's say you have a sine wave or something. I don't know. And then you know what this point is and what this point is, but then you want to know what is over here or something. So essentially you want to try to, interpolation is essentially predicting what number this is using this number and this number. Essentially that.
Okay.
Simple in concept, kinda complicated in practice.
Good thing we're not looking at that today. Right?
Good thing we're not looking at that today. We're just doing with the easy stuff today. Yeah, but yeah. So, do you want to start first, or shall I start first?
I didn't get anything ready. You can start.
Okay, I guess I'll start first then.
Yes.
Yeah. Maybe before this, I'll explain how we're gonna do this. So, to everyone. Yeah. So essentially, we're gonna be teaching each other and all of you. Oh yeah, by the way, for all of you, feel free to play along, and I might give some of you some prizes if you manage to answer the questions. But yeah, so essentially, we're gonna do like
answer wins.
What?
First one to answer wins the prize.
Yeah. Essentially, we're gonna be doing math. What does it look like in math? But whatever. And we're gonna be separating it into like for Nasa's prepared. Effa prepared like I swear my tongue. Effa prepared like I think like 3 levels. I prepared 4. We're gonna alternate between each other and see what we manage to like. Again, teach each other, and we're actually going like going from like easy to hard for all of the materials. But yeah, I'm gonna like reveal the material one by one. And yeah, welcome Matthew and Memes as they've been. Okay, so yeah, all right. So I guess like I'm gonna go first. Okay, so I prepared my first material. This is level 1. Boop. 2D geometry. This is what we're gonna do today for the first one. Okay. Now, first of all, I respect everyone's intelligence. As weird as that sounds, and I'm not gonna give you like I'm not gonna pretend that you're a grade schooler. This is like some grade school shit right here. Instead, I want to take a different approach to this. Like by the end of this lesson, I want all of you to be able to derive the formula for any shape, like even like the wonky shapes, like the shape of like. Let's say a tube of gum from like a simple triangle. So this is gonna be our main goal for this section. So yeah, let's start. All right, Nazus. If you fail this question, I'm gonna kill you. Tell me how to find the volume of this thing. Not volume, what you call it, the area of this thing.
Okay.
A square,
yeah,
a simple
got me
square.
With volume. But for area, I think it's this times this.
Yeah.
Right?
Yep.
Hey, got it.
This times
Let's
that.
Go.
Yeah, there you go.
Tell the tale.
Okay, good. Now, what about this thing? Wait, why is it looking? Why does it look like that though? Hold on, maybe if I do it on a different layer. I just quickly add that on a different layer. Oopsies.
Just skewed to a side.
Hold on, that's wonk. Hold on, it's Shift N, right? Shift N. There you go. Now it's on a new layer. There you go. Why does it look like that though? I don't know. Whatever. But yeah, it is just a regular triangle. A bit crooked, but it works. I'm gonna put it over here actually.
It should be this height times side. Yeah. Oh, divided times pi divided by 2.
What? What?
No?
What? Wait, what the fuck?
So just height times side divided by 2, right?
What the? When you pull the pi on a triangle, I freak out.
I forgot, okay? I haven't looked at this in ages.
I'm just like, I won't understand if you, for example, you forgot to divide by 2. I get that, but putting pi in there, I'm like, hold on a second. What has gotten into you?
Okay, so...
Oh god, we are drunk.
So I thought it was pi, okay. I forgot it wasn't pi.
Immediately I'm like, where did the pi come from?
Hey, there you go, it's fixed.
Yeah, okay, you know what? Okay, I take that. A pi on a triangle, yeah. Welcome. So, I saw Eva like put down a pi, and I'm like, hold up.
It was an accident.
Oh dear, what an accident, goddamn. Oh dear. I mean, I expect mess ups, but I didn't expect mess ups that spectacular, you know.
One of the shapes. I can't remember which though.
I mean, you get it like correct. It's like side times height minus 2. I mean, not minus, divide by 2. Oopsies, I can't speak. But yeah, so you get that correct. But here's like the real challenge. Again, I respect your intelligence, so you better not disappoint me. And all of you for in chat as well. Feel free to play along or like study along. So yeah, okay. Now the real question. Now this is what the less elementary school like style stuff. I want you to like tell me how you can derive the formula for like the triangle from a square. I mean, you're close. But that makes a right triangle. Yeah. What about this triangle right here? What about the regular triangle? How can you get the why is this formula side height divided by 2? Why is that? Yeah. Can you like tell me?
Why it's like that?
Yeah, why is this the formula?
Give me a second. I gotta think about that.
Yeah, so like this is more a lot of elementary school stuff. So which is why I'm doing this. It's less of an exercise in like simple geometry and more of an exercise in critical thinking.
Oh gosh, I'm bad at that. Okay. So why is it like that?
Yeah, why is this the formula?
I don't know what height means, to be fair.
Height is well the height of the thingy. Yeah, the height of the shape.
I know that, but I don't know why we use that instead of one of the sides.
What? Seriously?
I mean, they didn't teach me that.
Yeah, I mean, okay, I mean, honestly, that's kind of what I don't like about the school teaching system. They a lot of the times they teach you like these formulas, but they don't actually tell you how these formulas work. You know, that's why
why they are like that.
Why are they like that? You know, why are the formulas like this?
Like,
They just tell you to like
where's the
memorize
pie?
them. What do you mean? Where's the pie? What do you mean? Where's the pie?
I mean, they never explained me why I didn't have it. Why can't it be there?
Okay. Yeah. What about anyone in chat? Anyone in chat wants to try guessing why the formula is a side height divided by 2? Let's see. Someone in chat said they just left the origin of the formula to be explained in college. They never explained this in college. Come on, they never explained this.
Triangles in college.
It's actually like much simpler than you think. It's much simpler than you think.
I'm gonna feel stupid after you explain it.
You will. You will. Okay, anyone in chat wants to try? If not, I'm gonna continue. I'm gonna give you like 1 minute. And yeah, and while I was like, while we wait for chat to like, give their thoughts on it, I wanna ask something. What do you think pi is?
It's a number that just keeps on going.
I mean, yeah, I guess like, I mean that I'm completely fine with you not being able to like answer because pi is like, yeah. Sil actually did like, Sil did say something. Sil gave a hint, but I never actually knew how to like pronounce parallelogram actually, but like whatever. But parallelogram does have a similar formula. Like, do you know what the parallelogram is? That's actually the next one that I'm gonna give you, a parallelogram.
That's the one where the triangle has all the sides that are different, right?
That's not a parallelogram. This is a parallelogram.
Oh, yeah. Okay. Yeah, I know what that is.
Yeah.
Okay.
Yeah. So I'm guessing no answers from chat and from you. Okay. Here's how you derive of how this formula works from this. Okay. So everyone knows that formula for a square is like side times side, right? That's because, let's say you have you divided this into 3 squares. So if you have if one square is 1 unit, and then there's 3 over here, and then you multiply it by this, so 3 times 3 is 9. So we can all understand that, right? Right? I hope you understand that. I hope you understand that. Because because if we let's say if one square is 1 unit, so if we have 3, maybe I should change my thing color so it's different. So so if 1 unit, and then that times 3, you have 9 units. So so if one side is 3 wide, the entire thing should be should be 9 square units. But yeah. So anyways, now that we got that off the way, here's how we actually I don't know why I couldn't undo that, but whatever. I'll just remove this. Boop, there you go. Okay, now let's look at this from a different perspective. How do I deselect on this thing, Magic? I don't actually know how to deselect like this. Okay, there you go. But yeah, so let's this is your this is the first thing. You can actually do something like this. So this you can have this is the side and this is the height. See what I'm going with? So side times height equals the entirety of the volume of this thing.
Yeah.
Now, so that's already really close to the triangle formula. Triangle formula is SH divided by 2. So how do we get there? So obviously divided by 2, but how does it actually work? Let's say we have, you actually got really close over there on this thing. Let me show you. Let me make another layer and do this. So over here we have if we split a square in half, we get 2 right triangles. Right triangles, it's actually much easier to comprehend because, side, height, and divided by 2, we get the area of this triangle, right? Because, it's half of the square. But we can actually expand on this formula. Not formula, expand on this thought experiment, I guess. So if let me make a new layer. So if I take this triangle right here and like, you know, I make a square around it, I'm gonna get this thing. Now you see where I'm going? This is where we're starting to get closer to to get to this formula. So like the base of the triangle, like the S, and this is the H of the triangle, and then divide by 2. If you look at this is actually essentially just like let's say you take this square, it's like this S times this height, and then if you get the area of this square, you get like this side and this height. So if you can, you know, if you like calculate this on its own and this on its own, you divide by 2 to get 2 right triangles, and then you add the 2 right triangles to get this triangles. That's how you get to SH divided by 2. That's how you get to this formula.
Yeah. Yeah, I do feel stupid.
Yeah, don't worry, chill. But yeah, I mean that's essentially how you know how we're gonna start deriving formulas from a simple square. I mean, I guess like I could say triangle. This triangle is like the thingy that can make the most shapes. But yeah, so from here, now that you get like the gist of it, I want you to like, you know, explain the formula of this one. Oh, oopsies, I accidentally did it on an empty layer. But yeah, But yeah, so let me like show you now. So let's say we got this thing, a parallelogram. Yeah, can you tell me the formula?
I can try. Give me a second. Let's see. So I know we can do this. We've got triangles here. So the height times this. Wait, no, don't tell me.
Come on. You'll get it. You'll get it.
So I'm guessing you give me this. Whoops. I'm guessing you give me this number and this number, right? Like I don't know, 3 and 4.
Wait, where are we going with here?
I don't know. Han, give me a second. I'm trying to understand it.
I think it's weird. Like, you know, if you like, if you want to like show me what the height is, you can like do something like this, like boop boop boop, and then like maybe like 6 or something, kind of like that. That's how you explain what the height is.
Okay, so we've got height, we've got length. I'm guessing. So side, height. This would be the height. So we have x, y, height, and so x times height. Oh wait, I'm almost there. So we don't divide it by 2 because we've got this one. So x times height and plus y times height. So we can xh plus yh, which can be turned into h times x plus y, which is height times s, and that will be the solution. There you go. Height times side.
like this side?
Yeah.
Okay, yeah, you're actually correct. There you go. You got it. You got it. There you go. Congratulations. You discovered the formula for like a parallelogram.
The solution was way simpler than I thought it was gonna be.
It's actually just this, like, you know, this and times height. It's like side times, yeah, you know, you can that's usually when we say the formula, it's like this, you know, side times height.
Basically just like a square.
Yeah. Essentially, it's like the same as a square. But do you know why it's the same as a square?
Because if... Wait, let me get rid of all of this. Oh, I can't... Okay, let me just erase these. Right. There we go. So, what was the question? Why do I think that?
What's my... Wait, what was the question again?
Okay. So
oh, yeah, why do you think it's the same as a square? Or like, why is, you know... Wait, I
think it's the same because if we cut this and we pass this triangle over here, we've got a square.
That is correct. That's actually the solution I was gonna give you. That is actually correct. Like, if you cut this and put this over here, it is just a square, essentially.
Hey, let's go.
But
yeah,
yeah.
that makes sense.
Mm-mm,
The
yeah.
triangle.
There you
triangle
go.
explanation opened my eyes a lot.
Yeah. You better remember that because we're gonna use that until like the fourth level.
Oh no.
But yeah, like and then there's also the alternate solution, which is like if you split this in half, it's like two of the same triangles, and because the triangle's formula is like height times side divided by 2, if you remove the divide by 2, it just turns into a parallelogram.
Oh, true.
Yeah, that's like the other solution. But yeah, and alright.
Yeah,
okay.
that makes sense.
Yeah, I usually made thingamajig. This is like the illustration of the same parallelogram when you cut the thingy and paste on the other side. But yeah, okay. Now for the real deal. Whatchamacallit again? This is your real challenge. Now I want you to tell me what the formula for this shape is. There you go.
Oh lord. Okay, let's see.
Well, not really formula, more like the answer. But the answer is gonna be like for example 2x something y or something.
Okay, so if I do this. Don't mind me, I'm just sectioning it out.
Yep.
Wait, can I draw a square?
Can you?
No, I can. Not what I wanted. But wait, let me just do this. Boop, there you go.
Okay.
There you go. That works.
All right.
Let's see. So we've got a square. I'm guessing it's got to be a little smaller. Oh, that's the wrong thing.
You got this.
Yeah, I'll slowly get there.
While you're doing that, I'm gonna clean up the previous layers because I keep on making new layers.
I do the same. Oh, my brush is not. Here we go.
Did you mess up the selection?
I think I might have done. Wait, I can't draw anymore. Oh no, I'm not. Wait. I can't draw anymore. Give me a second.
What? Are you sure you're like you're drawing the right layer, and is your layer like on? And is your color like the same?
It should be. It should be. Oh, there you go. Ignore that. Yeah. Okay. So let's see. Let's say I'm not good at straight lines.
You don't need straight lines.
Okay, let's say this is a square. So here's a parallelogram, kinda.
Okay.
Here's a square and a triangle.
Okay.
Here are two triangles. Here's a square and another triangle. Okay. So this is X. No, we've already got X. This is Z. 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 What are you laughing at? Z.
You got this. You got this. Just like trust me.
Okay. Okay. This is Y. 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 Oh, we don't get it wrong.
You know that there's different sizes, right?
They are now.
Like I was like WW. Those are different sizes. Those have different sizes.
Okay.
Oh dear. Oh my.
Okay. This is W. Well, that should be W, I think. No, I don't think that is. Right?
Yeah, reading chat for a second. Yeah, welcome, Jared P. And yeah, need this because I have a test in 2 days. Thank you. You're welcome, I guess.
Yes. This is
I don't know if we're.
you can learn maths at.
I don't know if I don't know if what we're learning right now is like gonna show up in your math class, but you know what? Why not? Essentially, we're doing like doing elementary math, but like in a more advanced style for people who actually want to like know the origins of math, I guess, like how to derive formulas from like a simple triangle. But But whatchamacallit again? You know how it's just because I don't like how schools teach students by just telling them to memorize formulas, you know? So yeah.
That's how I learned, so here we are. Okay, so
Ooh, someone in chat actually gave a formula. I don't know what the fuck that is, but I think you're overcomplicating everything. My god. Still on chat saying it's like 0.5 times y times 0.5 times y squared plus 1/6 times 1 1 out of 6 times 1 out of 2 times y squared times 3. What the fuck? That is so complicated. I'm gonna show you what the real answer is. It's a lot simpler than you think.
Oh, okay.
I'm gonna show everyone later. It's honestly, it's like much simpler than you think.
Yeah, we've got a square here and 2 parallelograms, 4 parallelograms, and 2 triangles. Yeah, that should be easy. Don't think that's a solution.
That is not a parallelogram.
No?
It's a trapezoid.
Oh.
Like you're talking about this thing. This thing is a trapezoid, not a.
Oh.
Okay. Continue. I mean, if you want to continue, feel free to continue, though. No, I just want to say this. You're making this like way more complicated for yourself.
Probably am, yeah. Just give it to me straight. What's the solution?
You want to give it to me? You want me to give it to you straight?
Yeah.
Here's the solution. X, Y, 2. You believe that?
Wait a second. How can these make triangles? Wait.
It's just XY2. It's just XY2. That's the answer. It's really simple. Also, whatchamacallit again? Still said, yeah. I mean, still got the idea, but like I think you're overcomplicating this. I'm gonna show you later.
How to triangle?
What?
How does this?
I'm gonna tell you, it's not a triangle.
Then why is it a triangle formula?
Just because the formula is a triangle formula doesn't mean it actually is a triangle, you know?
Okay, so how do you chop this up?
Okay. It's actually much simpler than you think. So let's say let's do something like this. Boop, boop, and then boop. Boop, there you go, and then you move the 2 triangles like this. Wait, hold on. Boop, boop, boop. You make this shape, and then you attach it to this side, cut it in half, and then put it on the other side, and you're done. You get like half X and then like Y. Let me make it a bit better. So like, let me make it look a bit better.
I get it.
Yeah. So like, if I do this, we get like another thingy here. There you go. But this is like, we move this triangle over here, and then we move this triangle over here, and then this goes over here, and there you go. You got it. Because X can be divided by T. Yeah. Like if you like connect all the thingy-majigs, you can actually like see that this is actually like there's 4 triangles stacked on top of each other over here. That's why like X is like it's X divided by 2 over here. So essentially, it's like X divided by 2 times Y, and then I just simplified it into like this form right here.
Yeah. Now I get it. That makes sense. Yes, now I get it.
Yeah. It's much simpler than you think. But yeah, I was actually kind of hoping you would find like the other formula, which is actually just, you know, finding one of the triangles and then like just connect, like just multiplying by it. There's multiple different like solutions to this. I can do something like this, for example. If I like do this, you can actually find the size of one of the triangles. Like for example, like, you know, this triangle, it's like the base is y, it's like y divided by 3, and then the height is just like x divided by 4. So you can just like find the area of this one triangle and then multiply it by the amount of triangles you see here.
I mean, now that you explain it, yeah, it makes sense.
Yeah,
I don't know what
chat.
I was doing with the square.
Reading chat still said damn cool can't using the damn formula. I mean, honestly, like that's the problem is that you're just overcomplicating it. Some like again, like I'm gonna tell you, every single formula, every single shape that's like, well, you know, like that's not circle, because I'm not gonna get into circles. I'm gonna tell you why at the 4th level. But TLDR, I'm not explaining what gamma functions are. But like yeah, it's I don't think it's that related to pi, but like, oh god, gamma functions are painful. I am not explaining what gamma functions are, but I'm gonna at least tell you why. I'm not gonna like teach you why about circles in here. But you know, a lot of shapes, you can actually chop it down into like something simple and find the formula for it. But yeah, let's see.
Simplify it. It didn't work.
Yeah. Ring chat, yeah, Konkan is doing damage for now. Also, Jet P said, what are you guys trying to get here? Essentially, we're trying to like teach people like, for me, I'm trying to teach people like some basic geometry, but like not exactly how schools teach it. Schools like to teach kids by just making them memorize formulas for certain shapes, and I personally don't really like that, because that doesn't really, you know, that doesn't really explain why that's the formula. Why is a triangle s times height divided by 2? They don't really explain that. So I want people to actually like, you know the basics and how to actually find the I guess like area of shapes without actually without memorization. You can like get any like simple shape using just triangles or squares.
And
but yeah,
I'm trying to learn math.
But yeah, I guess, and that actually should be it for like 2D geometry. That's actually all the material I have. Yeah, I'm gonna put the thumbnail again because it's fun. That's level 1 2D geometry.
Cool.
Yeah, Raychat, Chandras, say your brain hurts. Oh come on, we're still on level 1. This is like elementary school stuff. Come on, it's just like shapes. Oh, it's gonna get worse. Trust me, it's gonna get worse. But yeah, and that's my material for level 1. So now it's like Effa's turn to actually teach me.
Okay, let's see. So my level 1 is. I'm trying to find it. Give me a second. I don't have any fancy images. I'm just gonna write it down.
It's okay.
I'm just looking for the name, because I know I wrote it down somewhere, but I can't remember. There you go. Fractions.
Fractions. Okay, sounds simple enough.
Should be. I mean, I can't really remember much of it, so it's not good.
Wait, how do you not remember fractions? I think you just used a few fractions.
Oh yeah.
How do you not remember it?
So let's see. How do you do this? You all know what a fraction is, right?
I think everyone knows.
Yeah. And this gives you a solution, but we're not gonna solve it. We're just gonna.
I mean, technically, x divided by y is already the solution. Technically, it's already the most simple form.
Yeah, so this should be our solution.
It's the simplest form.
So I do not have any like shapes to show.
It's okay. I mean, I don't think you can show shapes in fractions.
Yeah, I mean, yeah, we have like pizza slices, you know.
Pizza slices. That's a square like, pizza.
You don't know how I make pizza. The squares. So
the American pizza.
So how many pizza slices have I ate if the colored ones are the ones I ate?
the ones you ate. So
Yes.
there should be 6 out of 10 left, which is simplified. That's gonna be 3 out of 5.
There we go. That's the fraction.
Yeah.
It took me a while to like. I mean, I'm supposed to be the teacher here. Yeah. Okay. So, I guess this is like a visual representation. And now for the math part. So let's add and subtract fractions. We've got 23.
Fraction subtraction.
23 24ths minus a 4 minus 2 12ths.
Okay, that's simple enough. So like, what times 4 is 24? It's like 6. 6 times 4 is 24, right? If I recall correctly. So like,
Yeah.
so that's like, so we can write this down as we want to take this. This is like, oh, oopsies, I drew on a hidden layer. Oopsies, not the thingy. Let me make a new layer. Okay, so yeah. Also, welcome Zen has David, and yeah, Z-Face it's math is interesting. Oh, finally someone who gets it. Math can be fun. Maybe later I'll also explain some like funky concepts. But yeah, most of my material today is actually sorry, I was talking over you. What was that?
Oh no, that's fine. I'm just reading what Sen said. Look at these nerds with their math.
Yeah, look at these nerds with their math. Their math and their numbers. Yeah. Like, you know, like later, like right now, all my materials like relate to geometry in one way or another, just like, you know, for the thematic thingy magic. But later I can actually explain some funky concept that will be fun. But yeah, Let's see, ring chat, damn, where have you when I'm at high school? I could learn math from your face. I should be one of those, you know, like those Indian math tutors or programming tutors or something.
Yeah.
Yeah, but yeah, so essentially like over here, usually you want to like if there exists whatchamacallit again, a number that has a factor that is like that exists in the other ones, you can actually just write them like this: 23 times 24, and then because 4 is a factor of 24, we can actually multiply 4 by 6 to get 24, multiply the bottom to get 24, and then top is like multiplied by 6 as well, so 4 times 6, 1 times 6, that's gonna be a 6, and then minus 2 and 12 is also a factor of 24, so we can, 12 is just, 12 multiplied by 2 is gonna be 24, so we multiply that by 2. There you go. And then top we also multiply that by 2, so we get 4. And then we actually just like, you know, we just you know, what's it called again? Subtract the thingy. So that's gonna be like 23 minus 6 minus 4. That's gonna be 13 divided by 24, which we can actually simplify. So that should be the correct answer.
That's correct. Good thing you solved it because I. Not gonna lie.
Wait a minute. Hold up. Hold up.
You're smarter than a 5th grader. Congratulations.
Let's go.
Wait.
Reading chat for a second. To be honest, it always makes me happy when see Vtubers do educational content. Neat. I don't think it's like a thing that Vtubers do that often. But yeah, become the Indian math teacher of the internet to brighten my day. Yeah.
And
yes.
this part of the video was sponsored by mathematician.com.
Math aids? That sounds so wrong. It's like, you know, like math and then oh dear. I know it's supposed to be like AIDS and like band aids, but like AIDS, it's like, hold on, it's like AIDS, the AIDS. HIV AIDS.
Yeah.
Oh dear.
That's where I got the source material from.
I made mine myself because I don't think people actually teach math like that, like me. Yeah.
Yeah.
Someone asked what's called. No, there he's overseeing. He's the hall monitor. Yeah. So wait, is that all?
Yeah.
Okay.
That was this fractions part.
Okay. Yeah.
Yeah,
What
I guess I don't have the explanation of why that is, but hey, fractions! Let's go.
Yeah, yay! I mean, it's okay. You did something. Okay, then, like, whatchamacallit? Okay, fine. I'll give you one fraction question then. What's
Yeah.
22 divided by 7? It's already a base form, but can you turn it into decimal?
Into decimal?
Yep.
I can with a calculator.
For example, you know, like 1 out of 2
It's pi!
is 0.5. Yeah, there you go, you got it. But yeah, okay, but okay, I guess we all know what pi is. But I wanna ask you, how do you turn this form, like, you know, the fraction form, to the decimal form? How do you do that?
You divide it, no? Like,
But like, can you explain that?
1 divided by 2, you do a 0, you add a 0 here, you add a comma. 10 divided by 2, you get a 5.
Yeah, you're actually really close. Like, you know, like for more complicated numbers, can you do 1 divided by 4? What do you?
I can try.
Yeah.
Let's see. So it'd be. Oh, I need to get rid of this selection. My brush. So we get 1 divided by 4. We do a 0. We add a comma. Do a 0 here. This would be 2 because 2 times 4 is 8. We get a 2 here. We add another 0. Put a 5. We get a 0.
And yeah,
0.25. Hey.
Neato. Alright, you actually, I already explained that pretty well.
Yeah.
But essentially
Now,
the
don't
decimal
ask me why
form
we
is
add
like,
zeros.
yeah, you can actually see the decimal form as also like the percentage of like the thingamajig, like 1 out of 4. So like, you know, like if you say
good.
like 1 out of 4 of 100% is like 25%, so it's like 0.25. You can also say it like that.
Yeah, that makes sense.
Yeah. But yeah, anything else you want to add?
I thought about that.
Totally, yeah.
Yeah, no, that's maths. That's fractions for me.
That's maths. Okay.
Yeah, that's all the maths I need in my life.
Alright, I'm gonna like, I guess I should move to the next one.
Yeah.
Yeah, alright. Okay. Level 2 for me. Also reading chat. Since I'm American, I think it's 4 quarters. I guess. That also kind of makes sense. But yeah. Alright, next one. My next material. Trigonometry. We're going to middle school level now. Trigonometry. Hell yeah.
I know.
You know, trigonometry is like what you call again, a subject that I'm really salty about, just because back at middle school, the teachers didn't really teach me what this is properly, so I was super confused of what trigonometry is. But like, once I actually relearned it, goddamn, it's like simple as shit. But they make it sound so complicated, I swear.
Yeah.
Yeah. What do you know about trigonometry? I wanna see like you know your general knowledge.
I remember the angles. Can't remember how to solve for them.
What's the significance of the angles?
I know there's like sin, cos. I don't know what they are in English. I know them in Spanish. Like, oh, I can't write anymore. Give me a
Sine, cosine, tangent.
Yeah, that.
Yeah.
Tangent, cotangent.
Yeah.
I think it's called. I don't know. Yeah,
but the most you're gonna use is mostly just like, you know, sine, cosine, and tangent. That's all. That's the main three that you're gonna use. There are the others like, you know, cotangent, but like it's not that widely used. But yeah, it can still be used now. But yeah, so it's still like, you know, it's still for shortcuts and stuff. Okay, so trigonometry. So let's start with the basics. And yeah, reading chat pulling on the Python theorem. What the fuck is the Python theorem? I think you meant the Pythagorean theorem.
Python theorem.
Python theorem. The
snake theory.
Yeah, the snake theorem. But yeah, okay. So let's actually start from the basics. Okay, can you tell me the size of every single angle in here? We only know this one. Yep, correct. What about the others?
This is 45.
Correct.
And this is 45.
Correct. What about the others?
Oh, true. So this is 45. No, this is 90. This is 90. And this should be 135. So are these and these.
Yeah,
and
okay,
this is
you got all of them
45.
correctly. There you go,
Yeah.
that's the basics done.
Let's go.
Alright.
I remember because like this whole thing is 180.
Yeah,
Sorry,
there
my
you go.
spit,
That's
I'm
like that's the
sorry.
main thing. A line is always 180, and you know if one side is x, then the other side should be x 180 minus x.
And
But yeah.
the opposites are the same size. So yeah.
Yeah.
And this makes a circle, so this is also 360.
Yeah, circle is 360. Yep, that's essentially the basics.
That's
Okay.
way easier than the triangle shenanigans you pulled on the previous level.
Yeah, that's just the introduction though.
Oh,
Okay, let's
okay.
actually get to actual trigonometry. Okay, I actually only have one picture for this. The rest I'm gonna write because we really only need a right triangle. Like, so from a right triangle you can you know you can do a lot of things. But like what I want to teach you is mainly like how each side can relate to each other. So let's say this is what you call it again? Oh wait, where can I write? Here you go.
I had the same problem, yeah.
This is x, this is y, and then this is z. Let's say. All right. So do you know how sine, cosine, and tangent works for now?
I remember they've got like a set thing for each angle. Like I think 45 degrees is something like 1/2 for sine and something like that.
Okay. Okay, I guess I'll need to explain a bit then. Okay, so I think I'm gonna like use I'm gonna use some thingies. So let's call these like the slanted side the hypotenuse. I'm just gonna call it hypotenuse. That's like the slope, and then we're gonna call this side the opposite because it's like opposite of the angle that we're gonna use, which is over here. I'm gonna use 30 for now, maybe. And then we're gonna call this A for adjacent because that's the side that's adjacent to the angle that we're using. So let's use 30 for now because 30 is like probably the simplest one that we use. So yeah, you know how triangles always open up to like whatchamacallit to 180 degrees. So this one should be like 60 and this one should be 90. So how sine, cosine, and tangent relates is this. Sine equals. Sorry, I should get a tablet or something. Sine is always opposite divided by hypotenuse, the length of the thing, and then cosine is adjacent divided by hypotenuse. Sorry, I'm like doing this out of memory, so like you know, like, and then tangent. Tangent is just opposite and adjacent. But yeah. Ring chat, why are the letters in math? Oh, you have never tried discrete mathematics. Discrete mathematics is like a branch of mathematics that uses no numbers. You do not want to do anything with that. Oh dear, but yeah.
When there's words.
But yeah, so like this is essentially all the relations you need. Whatchamacallit again? You for this thing as itself, you actually would need a calculator to actually do it, and feel free to open up a calculator if you need it, because finding sine is kinda sucks, finding sine, cos and tangent kinda sucks. Like there's only like a few angles that you can do these things easily, and that's like the back then we called it like the special angles or something. I don't really know, but like I may just tell you. I don't actually know how to explain this in like in a way that's easy to remember, but there's really no easy way to remember this, so it's that's why this kind of sucks. So we have the sine, the cosine, and the tangent. and then this is 0 degrees, and then we got 30 degrees, and then 45 degrees, and then what's it called again? 60
37.
degrees. 60, yeah, not 60. It's because, you know, I mean, it's kind of like the funky angles, and then
I think
90.
there's a 37 one too, right?
A what?
37.
37?
37?
I'm not super sure actually, because, you know, like, again, this thing is like, I haven't found a way to like simplify this in a way like, you know, the geometry thingamajig. So it's kind of like, it's still a bit, you know, yikes, you know. But yeah, so let me just double check this just so I don't accidentally give like false information.
we fact check our maths here.
Yeah, we fact check our maths. Okay, we fact check our maths. But yeah, you can chat finally good content. Yes, welcome, Mr. Leg. Yes, use my calculator when doing these types of problem. Go tangent. Forgot. Yeah, that's a lot. Is the answer 14? We don't even have numbers yet. Oh dear. But yeah, so actually, hold on. Let me just quickly double check this with my calculator as well, because I'm actually scared of like messing this up, because if I mess this up, that means like, you know, it's incorrect and shit. But yeah, so let's put a half on this, half, and then half. A bit like a really bad handwriting, but hopefully you'll understand it. And then half on this one. Half on this one. Can you help me write this? Because there's a lot of halves. Like, essentially put a half under all the things.
Okay.
Okay, maybe start with 90 or something.
Okay, let's see.
Yeah, there you go. Thank you. I should have like, you know, I should have like made this beforehand actually. Because I just thought about this, because, you know, this like if you're using these angles like 0, 30, 45, 60, and 90, you don't really need a calculator to get the answer. But because it's actually, you can actually do something like this. So let's give the root of 0, the root of 1, and then the root of 2, the root of 3, and then finally the root of 4 over there. Yep, that's correct. And then start here with the root of 0, the root of 1, the root of 2, and it just continues like that. Yeah, and I actually messed up the tangent. The tangent is like nowhere near this. I'm just gonna remove that. But yeah, tangent is just like sine divided by a cosine. So like, you know, so it's just that. So just the top one divided by the bottom one. But yeah, that's the only thing that you need to remember when doing whatchamacallit again? When doing trigonometry is like these few angles. So essentially it's just like, you know, 0, 30, 45, 60, 90, just half, and then just roots going from 0, 1, 2, 3, 4. That's the sine value of all of these angles.
You
yes.
sure there's not
What?
like, you sure there's not a 37 angle there?
I'm pretty sure it's not for this thing. What even is the sine of 37? Let me see. 37, sine of 37 is 0.601. I don't know if that's like anything, like a thing. But yeah, but that's essentially it. Like if you want to eyeball it, you can do something like that. But and how you actually perform the calculations is that you usually I guess you don't need it. You can just use a calculator later. You can just, for those of you who's still in middle school and you want to screenshot that, feel free to screenshot that. It's like the easy way of like finding certain sine values without a calculator. Wait until they told you to look at sine 15 or something. Like if a teacher tells you to find what sine 15 is without giving you any values, they're evil. But yeah, so how would you usually do this? Is that, so let's forget about the table first. Let's imagine that there's no table. This is 30 degrees, let's say, and then what should we use actually? Let's use a 3 here and use a 4 here. Actually, I actually messed it up. Actually, nah, I mean, whatever. That was supposed to be a 5 by the way, but whatever. So let's say you have a 3 here and a 30 here. This should be 5, but can you tell me how to like actually do this?
let's see, it should be 10. So this is x, it's 3 over x, or then is half times 1 times 3.
Oh.
So, no? So wrong.
I'm not entirely where you're going. So, like, let's say, I mean, this one, I guess, this one you usually use a calculator for it. Also, I think I might have messed up the other side as well because I did a wrong thing with Jake. But whatever, don't ignore what I said earlier. But so usually you use, I mean, you can use the table here, but you usually can just use a calculator. So on your calculator, you want to type sine 30, and then just enter, and then you'll get 0.5. And then, so you can actually get the formula. You put it in the formula, and you get 0.5 equals the opposite is 3. So we put a 3 over here, and then over here is h. So the x, if you're thinking, but I guess, like, this is the hypotenuse, so this is the h. So essentially, you can like 0.5 h equals 3. H equals 3 divided by 0.5. So h is 6. That's legit the gist of it. That's pretty much it. That's all you need to know when you're doing trigonometry. I don't know why they make it so complicated on middle school, but like no, that's literally just it. The same goes for like the other ones. So essentially, like on trigonometry, they give you an angle or something else, and then like some values, and then you need to find out the missing value. That's pretty much it. So let's try a different one. So let's say I don't know. You mentioned 37 earlier. I'm kind of curious. Let's use that number.
No.
So let's say this is 37. I don't think it's you can use a calculator. It's not that difficult. Let's find the tangent or something now. So let's say the opposite is like the opposite is, I don't know, 6 or something. Let's just pick a random number. So I want you to find like, actually I'm gonna make you to find like both the hypotenuse and the adjacent. How's that? Try that.
Let's see. So that's 37 degrees.
I'm gonna solve it myself while I'm at it.
So this should be 0. Oh, can't write. Wait. Shift N. There you go. So 0.60 question mark equals 6 over h. So now we do that. We get our calculator and times this. No, that's wrong. Whoops. And divide 6 by this. That gives us. That's very wrong, I think. 9.96-ish. But we can now round it up to 10. So this would be 10-ish. Now we do the same for the other
just to like write the things.
What?
Yeah, I'm just pulling out my pen.
Okay. Ooh. Okay, so and for the other side, it should be 0.75 equals 6. This is a 6 over a. So a equals. Let's see, 6 divided by that. So a equals 7.96, rounded up to 8-ish. There you go, 10, 8, and 6.
Okay, wait, 10, 8, and 6. Where?
Yeah.
So the h is 10, and then the A is 7.9. Okay, the 7.9 I confirmed that was correct. I was actually doing that on my own, and let me just double check the H. Okay, so let me just quickly put it into the thingamajig. So I'm just gonna use sign because I think that's the easiest.
9.9.
Yeah, 9.9. Okay, hold on. I'm just gonna quickly like do that. Let me see. So sign. Let's get that. There, let's swap it. So it's like 6%. 6 divided by sin 37 equals 9.9. Yeah, that's correct. There you go, you got it. And yeah, that's essentially the basics. That's essentially the basics of trigonometry. It's just finding a side of a right triangle using one of the angles.
And I didn't even need to cheat.
Yeah.
Yeah, let's go.
But yeah, so okay. Now for the actual whatchamacall again, the actual challenge. Okay, so yeah, good job. You made Colin Sanders happy.
Hey.
Okay, so this question combines the knowledge you learned from the first level with trigonometry. So let's see if we can solve this. All right, boop.
Oh, no.
Find the area of the yellow side, the yellow areas. Find the yellow areas. And you actually, you don't need to you can assume the x is a number, or you can also keep it at x. It depends on your style, I guess.
Okay. So these are.
And you also don't need to exclusively use, trigonometry. You can combine it with the lessons you learned previously.
Okay. Okay, I need to look at this objectively. Give me a second.
Also, I might actually solve this on my own while you're at it, because I actually haven't solved this.
Oh, cool.
I know it's solvable. I haven't solved it myself. Let me get my pen.
Let's see. So this is also.
I'm gonna solve it on paper because so it's no spoilers.
Oh yeah.
Okay.
13, 16.
This, and this. There you go. Okay, on this sus. What do you mean on this sus?
Wait.
You don't really need to find all the angles. There are it's essentially it's squares, but you could if you want.
Wait. So Z and Y. This is the hypotenuse. So it'd be height times length.
Also, you should be glad I'm using all the the easy angles.
Yeah.
All the angles that you saw on the thingy on the table. So in theory, you can solve this without a calculator.
Oh, I didn't write the table down.
I can hold on. Can I make it? But yeah.
That's
There's a ring chat. Okay, have a nice day, Sel.
So sin of 16, yeah, 0.86. Okay. Let's see, I'm gonna assign an arbitrary number, okay? This is gonna be 4.
You can also
this is gonna be 3, this is gonna be 2, this is gonna be 1. There you go. So 2 times, no, that's wrong. 2 divided by this number. Oh, whoops. 2 divided by equals 2.3. Okay, this seems easy in concept. However, let's just do this, make sure there's no shenanigans being pulled here. Okay, so 1 square. This should be 5 squares lengthwise. That makes sense.
You can actually solve this without like assuming, like, without trying to, like, try to eyeball the square sides.
Ah.
I mean, then again, to be fair, I did, like, it is. I did. Shall I tell, like, something, like, give a hint?
No.
Okay, I'm gonna give the hint, but like, I'm just gonna tell you, you don't need to like try to eyeball any sizes. You can actually get the exact size for every single side.
Okay. Wait, I think the angles changed, don't they? Because this is 45-degree one. 45-degree also. Ah. Yep. Aha, I see.
You're getting it.
I feel like I can just cut the things and do something with that. Let's see. Let me just reform this. Shift 10. So Shift T. Oh, whoops. Okay. I'm guessing all these make 1 square. Need to figure out how that do. Wait, how do you do a line, Han?
What do you mean do? Oh, just click somewhere and then shift and click another place.
Oh, there you go. Okay. Click here, shift. That didn't work. Oh, there you go. Okay. Yeah, that makes sense. Okay, click here, shift. Okay.
I might have miscalculated like part of, like, the equation. I'm gonna make it easier because, like, I myself am, like, confused on, like, one part of the equation, but, like, I'm not gonna tell you what is it. I'm just gonna adjust the thingamajig. You haven't really, if you don't mind, that is, if you don't mind, like, because you're not gonna lose that much progress. It's just gonna be like some funky progress. So let me just move this down over here.
I've barely done anything.
Yeah. This will theoretically make it easier as well. So if I move this over here, there you go. And then same for, like, the thing down here. Theoretically, this should make it easier. It might be, like, maybe an error on my part. I was trying to, like, verify whether, like, this shape is actually possible, but, like, I couldn't really fully 100% confirm it. So I'm just gonna do this to make it so that it's a shape that's actually, like, 100% possible.
Okay, yeah, that does make it a little easy.
Okay,
not,
also
not
reading chat.
Easy, but easier.
Reading chat. Oh, sorry about that. I was trying to give here. Let me, like, show you what the question is. Find the area. Hold on, the yellow area size. There you go. Let me make this bigger. Can I make this bigger? Like this. There you go. There you go. Find the yellow area size. This is your task. What are you doing? I just realized.
Interpolating.
Sure.
Yeah, there you go. That works.
Yeah, it's the shade region. Find the shade region. I'm just perplexed by what you're achieving here.
I got 2 rectangles. I got a bit of the thing solved. Okay. So.
I mean, I guess it works. You know what? It actually works. Whatever you're doing, it could work.
Theoretically, it does. Theoretically.
Yeah, I don't know what the fuck you're doing, but I'm listening.
So yeah, let me cook.
I'm letting you cook. Yeah, someone says this is the equation, son. Let me cook.
Okay, so this should be a square, hypothetically. So
hypothetical square.
yeah.
Okay. And then you're gonna combine the middle one as well.
Yeah.
Okay.
So this should be x, and this should be x. So now what we do is do sin of x. Right, so this would be 0.8x. I don't think I need this anymore though. Do I? No, I'm complicating my stuff. And this should be x divided by 2. This should be x divided by 4, x divided by 4.
Mm-hmm. Okay.
And this doesn't make a square, this makes a rectangle. Okay,
what?
Go ahead.
Yeah, someone in chat said he's in Plato's realm of the forms, he is beyond our dimension. Yes.
My third eye is opening.
Yeah.
Okay, so these make a square. So this would be x divided by 4 times x divided by 4 times 2, because it's a rectangle. 45 degrees. So the hypotenuse of that would be
you're also free to you're also free to keep the sines and cosines in, by the way. You don't need to actually solve it if you it's more of a critical thinking exercise than a thingy-majig. You don't actually need to find the value of it if you want.
Okay, this would be
I mean, I certainly don't want to.
x divided by 4 sine, like sine of this. And this would be divided in half again, so this by 2. And now this is 45 degrees again. So if this is sine of x4 divided by 2, this would be sine of that. So sine.
This is getting whack.
Sine.
I think you forgot the angle on half the sines actually. By the way.
What?
I think you forget the angle of the sine on all of the almost all of the sines. Sine 45 degrees.
Yeah. Okay, yeah, let's fix that. Give me a second.
I was like, sine x divided by 4.
Okay, sine of 45 degrees. No, wait. Yes, that of sine of 45 degrees times x over 4. I'm going to the side, unfortunately. Okay.
It's okay. You got this.
my brain. So,
Truly a brain moment.
yeah. So that times sine of 45 degrees times x over 4 over 2, because we do that here, plus x over 4 times x over 4 times 2 plus x times x. There we go, that's your solution, Hanan.
X times X?
Yeah, this is
Okay.
x times x.
Reading chat,
That's
someone
maths
says...
for you.
Reading chat, someone says this is one of those Mad Genius movie montage seeds. Yeah. Okay. I'll be honest, I don't quite understand where you're getting at.
It's maths. I mean, what
Maths,
don't you
yes.
understand?
But yeah. Let's solve this together.
Yeah,
See,
sure.
someone says that's like trying to find the green rose. But yeah, let's actually like let's try to let's try to do this together. Let's see how we can actually solve this. Let me like get my brush size smaller. There you go. He won the Fields Medal. Yeah. Okay, so let's actually start from over here. Over here, let's get one of the triangles. Like, if we look back a bit, we really only need to find like the area of this triangle, and then like this to like get the entire, and then we need to just multiply it by 4. So we can actually start from there.
I mean, yeah, that's what I did. Obviously.
Yeah. So like starting from this, if this is x, then we can actually we can already determine that this side is like what's it called again? Let me actually double check that, because like I don't want to actually mess something up, So like we want to find like opposite adjacent. So like we want to find the adjacent from the opposite. So we need to use a tangent over here. So that's gonna be tan 60 equals, I'm gonna degree, tan 60 degree equals whatchamacallit again, opposite, which is x, divided by adjacent. So we can actually determine that this side we can mix it up a bit. So x equals a times, or like I guess a is like oh yeah, wait, hold on, a. Wait, I get the wrong thing. I was trying to find the a. I was confused for a second. Like, yeah, so a, which is the thing that we need to find. That's the big A actually, because it's like adjacent. There you go, big A. A equals x divided by tan 60. There you go. Okay. And then now let's actually let's, to make this simpler, let's actually take all of this, and then I'm gonna take the A, and then I'm gonna do this. I'm gonna assume that the A, I'm gonna call it y probably. Okay, I'm gonna call it y, and then I'm gonna take this, and then I'm gonna move it over here, all the way up here. So this is a formula that we stored. So, and then we can actually just get this again and type this as y. Oopsies. Where's my brush? Oh, I need to do this. Boop. So this over here is y. There you go. So now we also need to find actually, yeah. Now we actually already have we have this area right here. So that's gonna be just so we also, I'm gonna put it on the other side. So we have x, y divided by 2. That's gonna be this triangle. Let's call this what's
Oh.
I don't know, J or something, because this is gonna be we're gonna name off these. So J just equals this. Yeah, and yeah, there's Colin Sandals. He's the hall monitor. But yeah, so we get J over here. This triangle we call J. This is the area of it. And then now we need to find this one. How do you find this one? Let's start from over here. So to find the hypotenuse, we can use any of this. So maybe like we can use x and 60. So x and 60, let's see what it is. So opposite and hypotenuse is sine. So we need to sine 60. Let's call it again. Let's sine and then 60 equals, let's see actually, sine 60 is, let me just double check this, opposite hypotenuse, so that's gonna be x divided by h, which we need to find. So if we mix it up a bit, we should get h equals, let me actually brain this out. Oh god. Okay, opposite is on top earlier, so x divided by sine 60. There you go. Boop. Okay, so that's gonna be let's name that z or something. We're gonna run off letters really soon. Z, there you go. And then we're gonna do something like this. There you go. This entire thing is z. Okay, now let me just move this. We're gonna store this formula. If I can actually get it. Okay, there you go. Boop. Move it over here. Okay, so we got y and z now. Okay, now let's see. Where's my brush? Boop. There you go. Okay, so from here now we actually need to start whatchamacallit again. Doing what again? Oh yeah, getting the other angles. So from here, we can actually do something here because all of these are the same, the same triangles. We can actually say that this over here is 30. There you go, because 60, 30, 90, and then because this is 30, and whatchamacallit again, and a straight line is always 180. That's gonna be 180 plus 90. So this is 90 degrees right here. This is 90 degrees. So we can confirm that this is indeed a right angle. And then from here, let's actually see again. Let me quickly double check this. Make sure I'm not make sure I'm not doing something stupid, Okay, so this line over here, let me do this. Maybe a different color so it doesn't mess up. Maybe I shouldn't use the yellow, but whatever. I only got that's the same yellow. Let's use green or something. So let's take a look at this line. This line over here. And then this line over here they're parallel, so we can actually we can find this angle. So if you get parallel lines, wait, did I actually? I think it's part of the first lesson. I did explain on the first one, right on the angle side. So if we get parallel lines like this, yeah. If we get parallel lines, this over here should be 30, the opposite of the thing. 30, and then let me get my thing again. Just quick, what's the goal here? Oh, find the yellow area. Welcome, Rodolja. Has they been? We need to find the yellow area, the size of the yellow area.
I didn't realize you were reading chat, and I felt wait, did you actually forget what we were doing? I thought it was a question you were making.
Okay. So this should be 30. Wait, where's my? Oh, I forgot to change my color. 30. There you go. 30, there you go. And then if this is 30, this is 90, this must be 60. There you go. I'm not gonna do that there because that's gonna make things super it's gonna make things everywhere. 60, there you go. That's 60 degrees. So now from there we can try to get z. Now this is where the complicated part comes in. So to get z, we're gonna need to z is this entire thing. We're gonna need to combine both 30 and 60 from over here. I'm gonna like do another one. This is also 60. Okay, oh yeah, this seems like a work, but it is a lot of work. But yeah, think it like this is actually not exactly like, you know, teaching you the basics. It's more of an exercise in critical thinking. You're supposed it teaches you how to it teaches you how to like find values that you would have thought you couldn't find, I guess you can say. But yeah, so let's actually whatchamacallit again, do this. So we know that this side and this side is always the same. So hold on, where's my green? This side and this side is like, you know, it's the same because it's like a square. So from there, let's actually see here. Chicken good for a brain. I'm brain dead. It's okay. I mean, I actually did not try to find a solution for this before this stream, so I'm like doing it on stream live. Okay, so this one is like, let's see. So we need to find z. Let me like do this. I'm like, let me make it bigger. Hold on, make it smaller. Z equals like this plus this, which is and wait, to get that we actually need to do something else because the hypotenuse is the same. Let's see, 30. So we want hypotenuse opposite. Hypotenuse opposite is sine. So sine, let's see, hypotenuse opposite. So that's gonna be, I'm gonna just use x for now, divided by, I forgot the 30 again. I the same that you did earlier. XH, and then for this one it's gonna be 60 from over here, and then that's gonna be, let me see, let me turn my head for this. This is the hypotenuse and this is the opposite as well. Okay, so sine 60 equals x plus hypotenuse. There you go, because like this is this one is the one that we want to find. Okay, and then the h is the same. I forgot to equalize over here. Good name. Zukatua OG. I have no idea what that means. But yeah. Anyways, so on this side and this side, the x actually I'm gonna do y because it's supposed to be different. The h is the same. The hypotenuse is the same. So we can actually, if we mix this up a bit, we can say that x. Let's start from this one first. So hypotenuse equals x divided by sine 30. There you go. And then it's also equal to y divided by sine 60. I can't write. I'm really bad at writing. There you go. So from over here, let's see. How do we get it from over here actually? Oh yeah, actually z. So this is the hypotenuse, and we need the x and the y. And where the fuck do we go from here? Let's see. It's like memory help. The first letter of the word like sine opposite hypotenuse. Oh yeah, that. Oh yeah, SOHCAHTOH. Yeah. I just realized that. Like sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite. Yeah, SOHCAHTOA. Oh, thank you. Yeah, that's a really good like way of doing it. Yeah. So now we got this, right?
I wish I knew that when I was little. Yeah.
I can't remember like all the themagics, like all the tricks that they taught me in school. But yeah, so we got this, and then this is like XY. I should probably switch it to something like, because XY is like really difficult to like because I already have an X and Y. What's let's do AB or something. Oh, oopsies.
Little a, little b.
Yeah. Where can I write? Hold on. Did I get the wrong tool? Hold on, give me a second. Okay. Wait, what? Yeah, what can I write? Did I accidentally... Hold on, this is weird. Oh, there you go. Okay, now I should be able to write. So let's do little a and little b. There you go. So z equals little a, little b. plus little b. Yeah, I usually write b like this. Okay, let's see. Rain chat might get serious when you introduce emojis as variables. Yeah, but yeah, I mean, like later when we actually finish this one, we can actually like collapse the formula into like a tiny dot. Like right now we can actually already see some some things like j equals xy and then 2xy is over here, so we can like put it over here, and then and then z is like this thing, and then the z is also a plus b. We can start to simplify the formula after we're done with everything. Let me just quickly get this. There you go. And then I'm gonna grab this, but I'm not gonna grab the h because I think I'm gonna put a different variable for the h just so it's.
Wait, what happened to the sin of 30 and 60?
30. Oh, sin 30 and 60. Oh, it's over here. A divided by sin by 30, b divided by sin 60. It's when I was let me get my pen. So this hypotenuse and this hypotenuse is like the same length, so we can use this 60 over here and then this 30 over here. That's why we get the a and b. And then I guess for the hypotenuse, we're gonna use tiny c for it. Okay, there you go. Tiny c. I hope I won't lose track of everything.
Okay, yeah.
And tiny c over here as well. And then for this one is for this triangle, we can actually let's name it k. Let's name this triangle k. K is just let's see, k equals little c divided by 2 and then times little c divided by 2. There you go. And then we divide by 2 again. That's like little k. Yeah. You can just use Pythagoras. You have x and y. To get the z, let me just check this. Which z? Oh, well, let me just check. Oh, this z. I mean, yeah, normally you could just use Pythagoras theorem, but right now we're actually using variables, x and y for the thing, so it can get a bit funky. But yeah, right now, wait, should I teach Pythagorean theorem actually on this thing? Because it is technically part of trigonometry. I didn't really teach on the previous side, but essentially Pythagorean theory, just theorem. Wait, is it even a theory if it's always correct? So so to find the hypotenuse of something, you can do, let's say you have a right triangle. Maybe I'm gonna put it in a different layer just so I can remove it. If you have a right triangle and you have an x and a y, and then whatchamacallit again? How do I explain this? You want to find a z. Z equals the root of x. Wait, is this correct? I'm the one who's confused. Oh god, I can't actually remember the Pythagorean theory. I know it's I know it's something the root of something to power 2 and then something power x power 2 y power 2, but I can't remember if it's actually correct, Let me just quickly cross check that because I think I might have hold on. I might actually hypotenuse. Oh, okay, that's correct. Okay, I was super. Thank you for that, by the way. I was super paranoid because I'm afraid of saying something wrong. Yeah, so yeah. So I mean, that's okay. That's more or less the same. I usually write it as this. So a power 2 and then plus b. Oh, not 8. X power 2 plus y power 2. I was second guessing myself for some reason because it's been so long since I actually used this. I usually write it like this, but you can also write it how Rodo wrote it. That's also correct. But yeah. Yeah, that's the Pythagorean theorem. I actually didn't use it here because I don't know. I guess I just kind of forgot about that. But we can. That's also a valid solution. We can actually also use that. The result should be the same. Should. Emphasis on should. I hope I didn't miscalculate anywhere here. But yeah. So yeah, k is little c divided by 2 times little c divided by 2. And then divided by 2, we get this area. Oopsies, I drew on the wrong layer. Where's that layer? Okay, I think this is the layer, right? Okay, yeah, that's the correct area. Okay, so we got this area right here, this triangle. So now how do we get this other triangle? So because this is like this is a right angle and this is like 45 degrees, we can actually like pull a line over here. I'm gonna do it over here just so it's like, you know, just so it doesn't mess up the other things. We can pull a line like here, right, like this, and then because we already got the C, and this is like half C. Let's see. Usually for 45-degree angles, we can always say that, you know, this, if this is x and this is x, this is always x root 2. So square root 2. Let me see, x square root 2. So if C, let me just remove this. So if this is, let's assume this as like, I don't know, what letter have we not used? D. We're using so many letters, I swear. Let's assume this as D. If this is D, then this should also be D. And then I guess we can also like, you know, we can also say that this is already whatchamacallit again, D. And then root 2. This is the thingy. And from this, yeah, I'll start from like the middle. So the middle square, let's name it JKL. Let's make it L. L equals D, and then root 2, and then just squared, because it's like side times side equals the area of that. So we get that area, and then over here, actually we don't even need that. We don't even need that. This is D. Okay, we actually still need that. We still need to find D because we don't have the formula for D yet. So to find D, we're gonna need to we got the hypotenuse, and we got the right angle with like 45 here. So we can actually just get that. So that's gonna be opposite and adjacent. And you can also use other things, but like, you know, I'm gonna use opposite adjacent, which is gonna be wait, no, not adjacent. I mean hypotenuse. Opposite hypotenuse. So that's gonna be sine. So sine 45 equals like over here. Let me like turn my head because this is gonna get a bit confusing. Sine 45, that's gonna be C divided by 2, and then divided by hold on, is that even correct? Oh shit, I get backwards. My brain's starting to fry. Okay, so that's D because that's the opposite, and then we got the C divided by 2 over here. Let me like do this so it's like a bit clearer. But yeah, so this is like so from here we can get D. D is gonna be, let's see, if this is D, oh yeah, C divided by 2, and then sine 45. There you go. And I think we should have everything here. But yeah, this will be more case if you also need the angles. Yeah, it would actually. Oh man, I do not want to do that. But yeah, so oopsies. Did I accidentally? Okay, now that we got this, we can move this here. So let's see. We got do we have everything? Let's see if we have everything. So we got all these formulas. Let's see if we can get everything from this formula. We got D. D, so that's already good. And then we got C. D requires C, so we got C, and C requires A and B, and we do have A and B over here, which is like Z. So yeah, we can like from here. I'm sorry if this is complicated, but yeah, from here we can actually just get the area of this. Let's make a new layer. I'm gonna quickly like put a white canvas over this thing so it's a bit easier to see. Let's see.
Probably need that. We need that.
Oh dear. Okay, so now that we get all of these, we can actually just put them together. So, where is it? Where's my brush? There you go. So the area is essentially just 4J plus 4K plus L. That's the area. And then, you know, this is going to function territory. And then, you know, to get j, you just do xy2. So it's like 4xy2. So if we expand the formula, it's gonna be this 4xy divided by 2 plus 4, and then oh, let me zoom in. What elements does the colonel have to this example? Colonel is like the, you know, the hall monitor. It's like to make sure nobody runs out during class. But yeah, so k is like this. So like c2 plus, actually not, it's, you know, it's times c2. There you go, and then divided by 2, and then finally it's just plus. You know, do this as well, just like make it a bit clearer, and then just plus d root 2, and then yeah, and then it just continues on, like, you know, like xy is like over here, like we just continue like deriving the formula using formula, or like, you know, not deriving, more like you know, treating as functions. Like for example, if like we get x and y here, right? We can move this x and y over here. I can actually do that because like this is a different layer. But essentially, like this one goes into like this y over here, and then like this z is like, wait, what even is the z? I don't think we even use the z, but we do use the z for the a and b, and a and b is c. But like, so yeah, c, we replace this with like either one of these. And yeah, just like so on and so forth. We just continue like pulling the formula down until we get into the most complicated, I guess, because we are like unsimplifying the thingamajig until we only have x, which is the only variable in here. We just continue that until we only have x. And yeah, that's essentially how you solve this. If you wanna if you wanna derive that entire thing, go ahead. But like, you know, I'm not gonna do it because for time constraints. Never white right as 4 times JKL. Yes, 4 times JKL. Oh dear, I did not plan that, but you know what? That somehow works. Technically, that is the formula. Technically, that is the answer. Oh god, the answer turned into a shitpost suddenly. How did we get here? But yeah, that's essentially it. But I am sorry if you did not understand it that much. It was a bit more complicated than I thought. I was just fucking around when I made these things, but yeah. I hope we at least get the gist of it there. At least, you know, the gist of what I'm doing. I think I accidentally taught like functions while I'm doing this as well. Goddamn. But yeah, essentially that. I think it'll be a bit easier if we assume like the sizes. But I don't know. Who knows? It's probably gonna be like, you know, a million fractions or something. But yeah,
my solution. I think it's the same.
Oh yeah, let's show. Okay, this one is a first solution, which is what is this again?
it's sin 45 times sin 45 times x over 4 over 2 squared plus x over 4 times x over 4 times 2 plus, no, I think this is divided by, I can't remember, plus x times x. There you go.
I'm actually kind of curious. You know what? Later on, I'm gonna like, since it wasn't made for you, yeah. I'm actually gonna like try to post this on like r/they did the math and see what people come up with out of curiosity, because you know I'm honestly not super 100% sure if my answer is even correct. But you know, I hope I at least explain how to get to that answer.
I can't remember if this is a times or a divided by. It's been so long since I've done that.
But yeah. But ladies and gentlemen, that is trigonometry. I think I made it a bit more complicated than it's supposed to be. Now I kind of get why on middle school like it's kind of difficult to understand trigonometry. I think the teachers just kind of, you know, I tried to simplify it, but I think I made it a bit more complicated.
You did a fucky-wucky.
Yeah, I did a fucky-wucky on the example, but you know what? Why not? TLDR, the TLDR of the lesson is what Rodo said, which is like the best explanation. Just Sohcahtoa. Sohcahtoa. That's like that's the gist of trigonometry. That's essentially trigonometry. That's nothing else you need to know. You don't need to like do the stupid thought exercise that I usually do. But yeah, anyways, next.
So yeah, the answer is 4 times JK plus L. There you go.
Yeah, 4 times JK plus L. Yeah, smart.
Yeah,
Thank you for that, by the way, Rodo.
that was a good one.
Welcome to
let's
Crackhead
see.
Mathematics. But yeah, okay, so first level 2. What do you have for your level 2?
My level 2 is one of my favorite math equations.
Equations?
Yeah.
Wait, what's equations like? I don't actually know what equations are.
Wait, is it not called equations?
I don't know. Wait, can you give an example? I wonder what it is.
Wait.
Just continue with that. I mean, you're supposed to teach me, so tell me what equations are.
X plus Y equals 5. X minus Y equals 1.
Oh, those are called equations?
I think.
I forgot. I just know that those are algebra. I know. Equations is the most annoying thing with more than 3 variables. I guess. So they're called equations. I thought they're called algebra. Huh. Okay, makes sense. Yeah.
Okay, yeah. So it's
I guess it's part of algebra.
Equations.
2 linear variable equations. 2 variable linear equations. Yeah. Okay.
Yeah.
Tell me more.
So basically, you get your
essentially
variables here.
x plus y equals 5x minus 5y, I guess.
So to find the solution, you've got to move one of each, whichever you'd like to solve for, to the other side. So x equals 5 minus y. There you go. Now we know what x is, and we do the same here. So x would be 1 plus y. And now we've got two possible solutions for x. So we can do 5 minus y equals 1 plus y. Because
neato.
This would be x equals x. So now we do the same thing. 5 stays here, minus 1. And the y goes over to the other side with the sign being switched. So it'd be y plus y.
Wait,
so
hold. Oh yeah, never mind. I thought there was an error for a second, but nope. My brain just went highwire for a second, but yeah, okay.
So when we've got one variable or number going to the other side, the sign flips. So if it's a minus, it goes to a plus. If it's a times, it goes to a divided by. So here we've got 4 equals 2 times y. So this 2 goes over to the other side as a division. So 4 divided by 2 equals y. Y equals 2. So now we've got 1. And now we go all the way back over here. You pick your favorite one and we do x equals 5 minus y. Now we know what y is. So x equals 5 minus 2, meaning x equals 3. There you go. And now we've got our solutions. X equals 3 and y equals 2. There you go. And that's equations.
I forgot these are called equations. Then again, I guess I didn't really learn math in English.
I mean, I didn't learn math in English. In Spanish, this is ecuaciones. I don't even know if I translated that correctly. I got it wrong.
What do they call this in my language, actually? I don't even know what they call this in my language. I actually don't know. Like, actually, yeah, it is equations if I translate it literally. Like, 2 variable equations, linear equations. Yeah, it is called equations. The most difficult part about teaching in math in English is that sometimes translating things from your language to English doesn't translate well. Sometimes that just happens.
I did have to take a small trip to Google Translate.
So it is called equations. Okay. Can you do it with 3 variables? When it gets to 4 variables is when it gets really funky.
Oh no. Wait, I need to drink some water before that. Give me a sec.
Oh yeah, remember to hydrate everyone. Remember to drink.
Drink. So I've got another one here that's a little more complicated. This is going to be for you to solve, Han.
Yay.
I mean, it's still easier than your freaking square problem. But...
I am genuinely sorry for that. I did not expect that to become that.
Yeah. Oh, that was definitely a fucky wucky. There you go.
That's what I get for for making exercises on my own.
Oh, you actually did that one on your own.
Yeah, I make all of my equations on my own.
Oh gosh.
Just because funny.
That's why you should use today's sponsor, matheaids.com.
Matheaids.com.
All the math problems you can never wish for, which are done.
Reading chat, I don't want to be nerd emoji, but there's multiple ways to go at equations. Yeah, I do agree with that. And don't worry, hey, all of us are fucking nerds here.
No, it's my way or the highway.
Look at us, we're Vtubers, we're fucking nerds. We won't be here if we are not huge geeks. But yeah.
So x equals and y equals. That's what
also, yo, welcome. Yeah. Welcome, Scott from the Rock Galacticus, David. Yeah, all of us are more or less nerds, honestly. So, who cares? But yeah, okay. So first of all, I can already do something like, let's see. Can I actually copy this? Actually, I don't think so. Whatever. I'll just write it down again. So I can do 2x. Actually, first I'm actually gonna remove the bottom side. So I'm gonna just quickly multiply the 3 by 4 and multiply the 4 by 3, so we get per 12. So that's gonna be 4 2x minus y plus 3. There you go. Divided by 12, and then minus x. Actually, no. Hold on. 3, and then x minus 2y plus 3, and then do this.
Sorry, real quick. I like how in your stream it looks like I'm cuddling with Colonel Sanders.
I just realized that.
Just want to say you're fulfilling one of my lifelong dreams, so thank you, Han. I'm very grateful for that.
But yeah, and hold on, while I'm here, I'm just gonna quickly simplify this as well. Let's see. Boop. I'm gonna move the minus up here and then do something like this. There you go. That should be correct. And then I'm gonna do this equals, and then get the other one. So let's get 3x. This gonna be 12, right? Yeah. I just realized there's 2 12s. Whoopsies. I just realized there's 2 12s.
Just cross one out, there we go.
yeah. And then exactly. Later we're just gonna get rid of the 12. So we're gonna have 3x minus 4y plus 3. I'm sorry if I'm writing really slowly, it's because I'm using a mouse to write. And then plus, and then we're gonna have 4.
Forgiven.
4x minus 2y, and then minus 9. There you go. And then all of this divided by 12. There you go. And then over here you can just remove the 2 12s on the 2 sides. And yeah, I'm using a mouse. I don't have a tablet. I even draw with a mouse. The model you're saying, the one that's moving right now, I drew that with a mouse. I'm better at drawing with a mouse than with a stylus. But writing with a mouse is kinda Though to be fair, honestly, my writing with a mouse is better than my writing with a key, my writing with a mouse is better than my writing with a stylus. Just because I don't know, I just can't use styluses that well. I draw using a mouse usually. But yeah, okay, so we got this. So let's actually start multiplying the thing. So for example, this stuff. So that's gonna be 8. I mean, get close to colon Sanders this because we want some space. I'm gonna zoom in a bit just to make it a bit smaller. So we get 8, and then 8x minus 4y plus 12. And then this is important. We need to like do minus and then do parentheses here, because this is like this all should have its sign switch later. So we're gonna have again 3x minus again 3 times 2 is 6, 6y plus 9. There you go. And then we can open the parentheses later. Equals 9x minus 12y plus 9, and then plus 16x. Like in chat, bro, not gonna lie, my friend gave me the question. I'd be complaining a lot more. There's too much fraction business going on here. Yeah. Sometimes fractions can get really annoying. No, for me usually if I see a shitty fraction, usually I just, if I can, I try to use functions for it. If I see a shitty fraction, and that's just part of the bigger equation, if I can. But yeah, okay. And then minus
like small fractions.
Yeah. Minus y, and then minus 4 times 9. What the fuck is 4 times 9? Like 36? I'm guessing 36. I'm just gonna guess it's 36. I just hope that's correct. Okay, and then from here, we're just gonna quickly simplify it. So, let's go from over here first. So 8, wait, what are we doing up here? Let's see. We got 8x and 3x. Because there's a minus over here, that's gonna be like 8 minus 3, so we have 5x over here. And then we get minus 4y, and then 6y, that's gonna be a positive because it's a parentheses and there's a minus here. So that's gonna be 2 plus 2y. There you go. And then 12 and 9. 12 minus 9, that's gonna be plus 3. There you go. Let me just double check, make sure it's correct, because sometimes I like to do math with some of my math. Oh god. Let me just, yeah, okay, that should be correct. And then equals, let's go to the other side now. So 9x and 16x, we just add that together. That's gonna be 25x. And then 12 and 8, that's gonna be minus 20, oh god, 20y. There you go. And then finally, we got the constants. Plus, wait, no, it's supposed to be a minus because the minus is bigger. So minus 36 minus 9, that's gonna be 27. 27, there you go. Okay, now we get the simplest form. Like from over here, this is like all just fluff. We simplified into like this tiny 3 variables. But yeah, so, and then yeah, finally we just like, do the usual. Let's move x over here. So it's gonna be 5x minus 20. 5x equals minus 20y minus 2y. Sorry for like mixing it up a bit. I just want to like, make it look a bit nicer. And minus 30. There you go. Okay. Let's see. Reading chat. I'll be real. I don't know if setting the equal between both equations directly was the smartest thing, because it makes the solving bad, because you can use insertion or addition procedures. Oh, you can, but I mean, you can't do it effortlessly. I don't know. I mean, I guess like then again, I guess like it's with math, there's a lot of ways to like do things. I guess I'm just super used to doing it like this, but like some people do do it differently. I don't think that's a right and a wrong way, but yeah, it's just a matter of which one you're comfortable with. But yeah, I do agree. I guess like for some people, it may be a bit difficult, but for me, honestly, I don't really have that much problems with it, with insertion and insertion or addition with it. So I don't really have problems with it. But I see where you're getting at. But yeah, so from here we got minus 20x equals minus 22y, and then minus 30. All of this is minus. Okay, and then I guess we can make all of those positive because like it's, you know. So let's say we can say that x equals minus 22y minus 30 divided by minus 20. There you go. And then let's simplify that a bit because you know, I'm lazy as hell. X equals minus, can I like, how much can I simplify this? I think I just like, you know, I think I just like, you know, 11y minus 15 divided by 10.
Are you sure?
I'm pretty sure. Oh wait, shit. Oops.
Yeah,
Oops, my bad. That was my bad. Let's see.
There we go.
Reading chat, yeah, I feel like for the lack of a better word, I always try to compile or optimize my equations before actually doing stuff with them. Yeah. I see your point. But yeah, but hey, we got the x here. So, okay, so... Let me just like check this. Okay, and oh shit, I'm gonna like, it's gonna be whatchamacallit again. I'm gonna need to put this back in here. Okay, yeah. I see what you meant. I see what Rodo meant. Okay, so let's actually I'm gonna copy this and put it on a different layer. I see what you meant now. Okay, now this is where it gets annoying. Can I paste this? Why can't I paste that? Hold on, let me go back to, let me show this layer again. If I get this, and can I do this? Copy, and then, oopsies. I think this is this layer, right? Yeah, okay, copy this, and then can I paste it over here? Why can't I paste that? Yeah. Now I get what you meant. Now doing this is really annoying. Okay, I'm just gonna duplicate the layer, and then just, if I remove this, I can just, do this. Like remove this. There we go. And then we're gonna have this over here. I'm gonna put it over here. There you go. This is our previous one. I wonder if I can, I wonder if I can put somewhere else that's like a bit simpler. Yeah, this one. I'm gonna use that one because that's way simpler. I made it harder for myself. You guys will do it just the second step in the transformation. Yeah. I'm gonna use this. Hold on, let me like quickly. I'm gonna quickly let me deselect this. I made this more difficult for myself. Okay, there you go. Another copy, and then I'm gonna use this thing over here. Whatchamacallit again? Wait, what can I use again? Let me just double check this. Oh yeah, this. Oopsies. Let me just remove this. Remove this. There we go. Remove this. Wait, okay, there you go. And that. Alright, there you go. Now I'm gonna grab this and put this over here. And then this I'm gonna put over there. There you go. Now it's cleaner, much cleaner. And this is equals 4. Let me just quickly do that. Let me just quickly hold on. Can I even equal 4 that, considering, like, you know, can I even equal 4 that, considering I did do that? Equals 12. Oh yeah, I forgot you know, that was what I was thinking about. I did like do this thing. I mean, I feel so OP right now. I'm like middle school. Yeah. You can do it. Use the second step in the transformation to transform the equals 4 side equivalently. Okay, wait. I'm not sure which one is like the second step of the transformation is. Let me double check this actually, because like I know like over here I made this. So this equals this. So this equals 4. Let me just double check everything, just because I don't want to mess this up, you know.
Yeah.
So like, you know, we know this is equal 4. Welcome CJS David. We're doing maths today. Okay, so I'm gonna like re-add the 12 here just for like this, because you know all of this is equals 4. So if we want to remove the 12, it's gonna be like, you know, we're gonna need to like multiply this by 12 as well. Right, I don't use strong term for big. Yeah, it's okay, don't worry. You know, sometimes it can be hard doing this in English. So yeah, so if we multiply this by 12, we can remove these two. So we do, yeah, that's what I was like thinking of. So we do need to use 4 times 12. So that's the simplification. So 4 times 12, let me just quickly go to the other one. But yeah, mental abuse to humans, exactly. We're abusing everyone mentally. But yeah, so over here, I'm just gonna quickly do this equals 4 times 12, that's gonna be 48. 48. There you go. So now I can actually start. I said I made it was way too complicated. So yeah, so I'm gonna use this one over here. So let's do 5. Mainstream and femboy tag just kind of fit. I don't know, I don't know why, but like in STEM fields like science, technology, engineering, and mathematics, there's a suspicious amount of femboys. But yeah. 11y plus 15 and then divided by 10. There you go. Plus 2y plus 3 equals 48. There you go. Now, oh, I swear. I hate myself for this. 55y plus what the hell is 15 times 5 again? My brain. Like 75, I think. Okay, yeah, 75. 75. There you go. I think. Let me actually hold on. Calculator. Calculator, help me. 15 times 5.
It is 75.
Okay. Okay, there you go. Divided by. Do I divide by? I don't even know my basic arithmetics at this point. Do I even divide this by like what you call it again? By 5? No, right? It should still be 10, right? I swear, my brain is breaking. I'm just gonna quickly calculate this for a second, just because I am very like. You know that paranoid feeling you get when you're like, when you're not sure if you're like doing something correctly.
Yeah.
Yeah, that's what I'm getting right now. Let me just quickly like check that.
It's called anxiety, bro.
6 divided by 10. Thank you, Rodo. But yeah, I'm just gonna quickly calculate this, just for like formality and because I'm like paranoid. But yeah, thank you for like the clarification though, Rodo. But yeah, sometimes my brain just breaks. 10. There you go. Okay. All right. Yep. Just make sure just need to make sure that that's correct. Just because. And then plus.
Divided by.
Let's 15. Like yeah. I'm actually gonna whatchamacallit again? Multiply this by 10 just so it's like all the same. So that's gonna be 20y divided by 10. There you go. And then I'm gonna move this over here. So that's gonna be equals 45. There you go. Ring chat, I'm only in high school myself, but I'm the king of middle school maths. Hell yeah. Like I hate how like how I hate how we get maths after we're done with that grade of math. Like when you get to high school, you suddenly understand all middle school math. I hate that, but yeah. But yeah, so we got this. So let's simplify this. So we can remove this and remove this. So and then we can like this plus this. Wait, hold on. Don't do that first here. Don't do that first. Let me like. So if I first remove the plus first, and then I'm gonna remove one of the 10s. If I wait, why can I do it? There you go. And then get my brush. Let's connect these two. There you go. And then if I remove this, yeah, I can just remove the 20y because 55 plus 20y is the 75y. We get a 75y. Boop. 75y because that's 55 plus 20y equals 45. Let me move that. Rain chat, I went through hell, kinda good. My paper 1 and 2 was Gucci, paper 1 kinda. Wait, oh wait. paper? What do you mean paper? Like is CJ doing a paper, like college paper or something? But yeah, so we get this. We can like do some, like move this over here. So there's like 450. Boop, there you go. Because we multiply both sides by 10. There you go. And then we move the 70. Wait, where did 75 come from? Oh yeah, the 15. Oh yeah, the 15. Yeah. We move the 75 over to the other side. Or we can actually just divide everything by 75 first. Let me just divide everything by 75 first. So 450 divided by 75, that should be 6. So it should be like let me get it. Where's my brush? So y plus 1 equals 6. So y should be 5. There you go. Y is 5. We got that. I swear. Yeah, Vtubers this year. Yeah. How's your day? And yeah, I'm doing good. And yeah, this is Eva, by the way. But yeah, okay. So we got y is equal 5. Let me like put this over here. And then to get that, we can actually just insert it over here. So that's like 55 plus 15 divided by 10 equals x, which is equal to, let me just quickly, I'm just gonna calculate it because I'm too lazy. 55 plus 15 equals 70 divided by 10. Okay, x equals 7. There you go. X should be 7. His face looks like he's crying, maybe. Okay, and x is 7. Is that correct?
Yeah, that's the answer.
Is it? Wait, is it correct or not?
It is correct, yeah.
Let's go, hell yeah.
It took you longer than I expected, but yippee, man.
Yeah, I think it's mostly because I'm using a mouse for this. Oh dear, but yeah. Ta-da!
Ta-da!
I don't know what I'm supposed to say, but here's your answer.
I was thinking of getting a harder one, but nah.
I don't think this is like that hard. It's just really tedious. I mean, then again, I could say the same for my previous one.
Yeah.
This is really tedious. Oh, I mean, honestly though, thank God it's not 3 variables.
Oh no, I hate 3 variable ones.
Yeah, even 4. 4 variable, I'm gonna vomit. If you give me 4 variables, I'm just gonna refuse to answer that.
I'm not doing that. You can't pay me to do 4 variable math, you.
Reading chat, CJ said, now what if we use the quadratic equation? No. I refuse. I refuse. Oh dear. But yeah. What else do you have to say?
I hope you enjoyed it. That's my favorite type of math. Yeah.
Very neat. Alright. I guess I'm gonna pop this then. And yeah, alright, I guess we'll get to the next subject then, like level 3 of the thingamajig. It's gonna get worse from here. But honestly, mine actually gets a bit better because like compared to the previous one, this is like much nicer.
I hope.
I think chat for real stuff with actual human is like a war crime. It is. Nowadays I use that Wolfram Alpha for all of those shit. And yeah, way too broke as to derivating.
I'm touching that with a 10-foot pole.
I was tempted to do calculus, but like I'm like no, I don't want to do calculus. But yeah, all right, level 3. Level 3 is actually an extension to like what I was teaching earlier, from like 2D geometry to trigonometry. Now we're doing 3D geometry. So we're doing it in 3 dimensions. Yes, 3D geometry. Yeah, this shouldn't be that hard though. But yeah, I'm gonna teach you in a similar way to the previous one, which went to the what's it called again? The basic geometry one, the 2D geometry one. Yeah. Somebody remembering his formulas? Oh god, like I mean, are you talking about like derivatives or like geometry? Because if you're talking about derivatives, I agree with that. But if you're talking about geometry, then hey, like later you can try watch the VOD on the first area. I taught everyone how to get the formula for any shape using just triangles. Well, not any shape, like most shapes. Technically, any shapes if you if you don't use absolutes. And so it's 5 seconds. What's the surface of a square prism? It's like the base times the height. Easy. Like like square. Like I mean, this is technically a square prism. So it's like the every single prism is just base times height. The base is always the formula of the 2D shape. But yeah. Okay, I guess I just like told what I was thought what this one is supposed to be. Oh shit, surface not volume. Okay, I'm sorry about that. I did not read that correctly. But yeah, I guess you can say if you're talking about a square prism, then it's like it's just all the sides. You can just like find if you have the width, length, and height, you can just like find the width, length, and then that's like one surface. Multiply that by 2 to get the other surface, and then like do also width and then length, and then height and length. That should be like the first surface. Surface is kind of like annoying though. I do agree with that. Later we actually will get into this. But yeah, okay. So yeah, forever. Tell me the formula of this thing.
Is side 1 times side. Oh wait.
But yeah.
Why is not writing?
Reading chat. Reading chat while doing this. Yeah, I agree. Surface formulas can get really annoying, mostly because it's like it requires a lot of like doing things, a lot of like adding up surfaces most of the time. At least in my opinion, that's what's annoying. Is it hard? No, but is it tedious? Yes.
It's side 1 times side 2 times side 3.
Yeah, correct. That's like the formula for like a square prism. Keep that in mind because we're gonna use that for the final lesson later, which is like the one that's kind of like funky, the one that all of you probably would be interested in actually, because like it's not something that they teach you in school.
I'm just imagining the square thing you showed me before in 3 dimensions.
Yeah.
Calculate this.
Reading chat. At least for prism is in my language. The idea is you got 2 times the ground plus the mantle. I mean, yeah, I guess that makes sense. Like, you need, like, for any prism, like, it works for cylinders as well. You just need the, let me, like, show it. To find the surface area for the prism, you just need the base, the top. I mean, if it's a prism, then, like, it should be the same size. So it's like the base multiplied by 2, and then you need to count the mantle, which is not always, like, it depends on the shape of the base. But yeah, okay. Now, alright. I don't think I'm gonna get too much into like surface equations here. I mostly do volumes. I don't know why. It's like I just like to forget about surface area. Maybe it's because it's just like it's just a more complicated version, or not complicated, more like a more annoying version of 2D geometry. Like if you're trying to find the surface area of a 3D shape, it's just the 2D shape, but with extra steps. I guess. But yeah. Okay, so now I want you to like kind of like previously. You know how earlier I told you to like tell me why the area of a triangle is like the area of a triangle. I do this.
I think I know this one. Okay.
Yeah. So, if you do surface, I have to end Twitch. Yeah. I mean, I'm mostly gonna touch on whatchamacallit again, thingy here. Oopsies. I'm mostly gonna touch on volume, but I might do like a tiny bit of surface area. But then again, it's not gonna be anything like complicated. It's just gonna be adding up surfaces. Maybe just a tiny bit. I don't know. But yeah, okay. Now we got a pyramid, a square base pyramid. Can you tell me the formula for the volume of this thing?
It should be height times half of this. So height times side divided by 2. Wait, don't tell me.
You got me you handed me the formula for the area of a triangle.
Yep. Give me a second. Okay, wait. I thought I had this on the bag. So we've got side 1 times side 2.
No,
That's
to,
for the
to give it to
base.
you, it's a lot less intuitive than the triangle one. It's a lot less intuitive.
Oh gosh. Okay, so we got the base, and then we got a. I don't know. I can't remember this.
Okay, everyone in chat. No, there's no square root involved. There's actually not a single square root involved.
Times height, maybe. Divided by 2. There we go. That's my solution.
I mean,
wait, I forgot. Times pi. There you go.
Where did the pie come from again? Oh no, the pie made a return. What the fuck?
That's my final answer.
Oh god. Okay. I'll just say it, I guess. Like okay, so if I'm gonna call this like a prism, and then I'm going to call this like a actually a cone, because like technically a cone is like the best description for this, because later you're gonna know why I'm calling it these things. But yeah, so a prism's volume is always base. I'm gonna do this, base, and then times height. So it's always base times height. The base is always like different. It's different depending on the shape of the base. So if the base is like a triangle, you need to find a triangle. If the base is like a circle, you need to find the area of a circle. But essentially, whatever that area is, you multiply it by the height of the thing, and you will get like the volume of this entire thing. But for a cone, on the other hand, a cone is similar to this, but it's just the base of the thing times the height divided by 3. It's always that.
That was close.
Do you know why?
Got one number wrong. Yeah, I'm guessing it's because if you get all the empty space and you turn it around, you get another pyramid or something like that.
Not exactly, but this one is like very unintuitive. So I don't think I can explain it in the same way I explained the triangle previously. But yeah, 3 cubic. Yeah, 3 cubic. CJ actually, like, you know, CJ, the best explanation is what CJ gave, but it's not exactly that intuitive. That's the problem. Like on the previous one, like if we go on the previous one, I actually explained how you can let me actually remove this for a second. Previously on the first lesson, I taught all of you that a triangle, you can actually get the shape of a triangle by oopsies, that's still hidden. You can get the area of a triangle, not that one triangle, a different triangle, by like dividing squares by 2, like just slicing it by 2. The same concept is applied to like the cubic version, the 3D version of the shape, but it's just like a lot less intuitive. Can we just stop it at the volume of the cone is base? Yes, the volume of the cone is base. Why not? But yeah, that's essentially it. And yeah, this actually goes the same as like for all shapes. That's like, this is the basic formula. I really don't like how some whatchamacallit again, some teachers teach how to like teach them like individually, like, you know, the volume of the pyramid, square-based pyramid, and the volume of the triangle-based pyramid. I think it's much easier to just tell them that it's just the base times the height divided by 3 for like if it converges into a point, or just base times height if it's like a prism. But yeah, surface area though, I'm not getting into that. Especially the surface area of a cone. The surface area of a cone is no, just no, bad. Do not try to find the surface area of a cone. Okay. But yeah, so essentially that's essentially the basics. Now, this is where we get into like the more funky stuff, I guess you can say. Let's see, let me get my thingy. Let me get my pictures. There you go. Alright. I'm gonna remove this for now. There you go. And this. Now, I want you to use the lessons in the previous lessons, what you learned in the previous lessons, to like find the area of this plane now. Reading chat, hey Peter, the surface area of a cone is not that hard if you finally use Pythagoras. Oh no. But yeah, like, I'm just gonna assume that this is X. Yeah, you can assume this too.
Okay, thank you.
Reading chat, if you wanna skip this section of the test, okay, like, this is a nice spot in to test to get some marks, but also not useful if you can skip, I guess.
So
the surface area of a cone is not that hard if you finally use Pythagoras. Oh god. Cone surface area is so annoying though, and that's something that I still don't get those days. I mean, I get it, but like, I don't know, it's just painful. I don't want to deal with it. TLDR.
Okay. Wait, what's the square root of 8?
Basically, for learners that only want to get above 50 but want more. Okay. Bro, even this guy used Pythagoras right now. Yeah! Wait, why is this root of 8 though? Wait, is it? Oh wait, oh yeah, I think that is correct. Yeah, my bad. That is correct.
2.8. That's just 2.
I honestly, fun fact, I honestly prefer like the root form because like decimal is usually really funky. You need to round it up and down and shit. But yeah.
Yeah, that's true. Let's just.
Isn't the theorem of Pythagoras?
Okay, so this would be right? 2 divided by 2 this?
Yeah.
Is that the answer?
I'm pretty sure, yeah. I'm pretty sure this is the form, yeah. At first I thought you were gonna go for like, I thought you were gonna go for like 4 this, but like this is essentially the same thing. But yeah, same thing.
Yeah.
But yeah, it depends, it depends on how you do it. But yeah, if you use X for the thing, it's also like, it's the answer is gonna be X. My brain suddenly just like malfunctioned for a second, like, so it should be, wait, no, it should be, because it's X times X root 2, but so essentially this is the formula for like this plane right here.
Okay.
But yeah. Okay, that went kind of weird for some reason. I don't know why, but whatever.
Yeah,
it is what it is. Yeah, it is what it is. I don't know why my brain kind of got fried for a second, but you know what? That works. Reading chat.
Yeah.
Surface isn't that hard really. Just imagine a triangle of the base on one side. Just imagine a triangle where half the base is one side and the height is the other side, and then just calculate the area of the triangle with the hypotenuse of said triangle. Kind of wacky. Wait, surface? Wait, which surface? Surface of a cone?
What?
Surface of a what now? I can't remember I actually can't remember the formula of the surface of a cone actually. Just because it's such a niche thing that I don't really think about.
I don't know what the difference is between surface, area.
Surface is essentially like the area, like let's say you have a cube, and then you measure the area of each side of the cube. That's, yeah.
Oh, that's the surface, okay.
Okay, reading chat. Imagine a triangle where the half of the base is one side, and then the height is the other side. Oh! Oh, now that you mention it, oh yeah! Okay, you kind of like, oh, for some reason, I don't know why, but for some reason I thought of I don't know why, but I thought if you unwrap a cone, you'll get like a circle. But no, like that does work. You can actually do. Wait, wait, hold on. Oh, wait a second.
Wait, while you ponder about that, I'm gonna go pee real quick.
All right. Here's the thing, though. Like, if you unwrap a cone, this is what you get. Like, let's see. Like, let's say this is the base of the cone, right? Let's assume that's a regular thingy-majig. The unwrapped thingy you'll get is gonna look like this. So this is like gonna be the height of the cone, and then this is gonna be like the other side. And then the one that stumps me is like how this is actually curved and not straight. if it's straight, it's gonna like create an uneven base. So it needs to be like it needs to be like round. Actually, I'm pretty sure, right? I hope I'm not mistaking this. Hold on. I hope I'm not. I didn't do this wrong. Cone unwrap. I'm pretty sure if you unwrap a cone, you have like some sort of yeah, kind of like a triangle, but the base is like the base is round. So actually, let me like do something like this. 1, 2, 3, and then do this. The base is round, and it's like it's a lot. It's how big is this depends on like the height. So if you have like a really short height, right, like this, it might do something like this. So like kind of like this. So that's kind of what what always like messed me up. Oh, cone is not the same as a pyramid. Yeah. Oh, okay, yeah. A pyramid is different. Yeah, cone is the circle base. It's the only one that like it's the only one that really stops me because of the shape of the thing. But yeah, pyramid is not that difficult. Pyramid is just all the sides and stuff.
I like things with angles.
Yeah. Yeah, again, there's a reason on the first lesson and on this lesson I'm not teaching circles. There's a reason for that, and I'm gonna tell you why. Again, I am not explaining what gamma functions are. For those of you who know what gamma functions are.
Never heard of them, and I'm glad.
And you will never hear of it up until like, unless you're practicing theoretical physics.
Oh, heck no.
Yeah. Oh dear.
My fractions, thank you very much. No, not fractions, equations.
Equations, yeah. Alright, but yeah, actually you did that flawlessly, very nice. Okay, and then last training one before we get into like the actual question, which is actually pretty simple on this one. There you go. What about this one?
Oh. Okay, this is... Can I put a number to it?
Yeah, you can put a number or you can also use X. It depends on your your preference. 3 is a good number for this.
3. Yeah, because this would be 1, 1, 1. So we first divide this.
This combines all 3 lessons.
Oh, yeah. So this would be
okay. I love what Rodo said. If you want to calculate anything, just use calculus approximation. You know what? Why not? Why the hell not?
Yeah.
You technically could. And you know what? If you want to find the volume of anything, just throw it in the water and throw. If you want to find the volume of any rock, just throw it in some water and see how much water comes out of the glass if assuming the glass is full, and you get the volume. No need for these maths and stuff.
Yeah, that's definitely an easier way to do it. Way easy.
Like if you want to find the volume of a cube, fill up an entire glass with water, plop the cube in, and see how much water comes out, and then just measure that with like some physics shit. 500 IQ, yeah.
See, I'm getting there slowly. This would be 9.
Reading chat right on the test paper proved by actually doing it, yeah. I mean, imagine writing a paper about that. Apparently you can find the volume of something just by putting it in water. And then calculating the water's volume using like, like its weight and what's it called, mass.
Same answer here, that's weird.
Yes, the Pythagorean theorem.
I don't think this is right.
Huh? Wait, hold on, what?
Yeah.
Wait, hold up. I actually kind of think it's because you use 1 for the thing. I think it kind of went whack because you use 1.
Probably.
Yeah.
Let's see, let's use 9 then.
Yeah. Reading chat, what did you calculate the last thing? Just cut off paper that has those little squares on it. Oh yeah. Actually, good point. I should teach all of you that. I used that trick multiple times on on exams. Oh dear. Because sometimes you know how like they give you like a shape and then like coordinates and stuff on a grid with coordinates and stuff, and you need to find the area of the shape. Sometimes I just like to count the squares. That's actually a valid trick that you can use. So if it's like if the square is full or more than half, count it as full, count as 1, and then if it's half, count it as half, and if it's less than half, count it as 0. If you take all of that and then you know, just add up everything, it should be the approximate volume or like surface area of the thing with the shape. I think same works for like for you know 3D space. But yeah, approximation wins again. Remember, kids, approximate. In the real world, there's no such thing as absolutes. Everything is relative. There's no such thing as an absolute volume. Everything is always an approximate. Therefore, we therefore just approximate everything. Pi is about equal to 3. Good enough, yeah.
This one, give me a second. Okay. This is a try hard moment. Try hard moment.
Wait, hold on. This is yeah. Also, reading chat. Why do we do math? I don't know. It's just a funky stream idea that we thought of.
Yeah.
I was doing my homework while watching Eva stream, and I was like, you know, Eva asked me, what homework? And then I just gave like the equation and shit, and got the idea. Math stream. Reading chat, what do you even call the shape? I mean, the shape of the area is a trapezoid, technically.
I'm messing up here.
It's technically a trapezoid. You're essentially just like, you know, you're essentially just using the previous lesson, trigonometry, to find the area of a trapezoid. This is a vil of view? FOV, kinda. In a way, kinda.
That makes sense.
Okay.
I need to open ChatGPT.
Hold up. You may be overcomplicating it a tiny bit. Yeah, it's true to mention. Yeah, actually, now that you mentioned that, I also love how you use a question mark as a variable. I've never seen that before.
Oh, yeah.
That's wonk. I love it.
Okay, so how do you simplify square root of 162? I know it's 12 something. But...
I'm not gonna try that. I'm certainly not gonna try that. I mean, like you can calculate it a bit. The calculators like to spit out funky numbers.
Yeah.
So then again, I don't have one of those fancy calculators. It should be 12 and then root something. I'm guessing like 18 or something. I am not factorizing that.
81. That's
what a Google guy. Yeah. Irrational numbers.
Yeah.
This is irrational. Why are you doing this? It's irrational. My god, this is funky. You got this? Kinda.
There you go. So it's square of 2 times 3 times 3 times 3 times 3.
So it's like 9 squared root 1. 2. No, shit. I think I messed up. So you can take out the 3. You can take out the 2.
Yeah, 2 9s. So it.
How did he? Wait, hold up. How did we come back to this? Hold up.
What?
Wait, hold on.
This is.
Just continue.
Okay, so this, I think. So this.
Oh yeah, that's correct. I thought you meant the other side. Yeah, that's actually correct. That's correct.
Yeah, there you go.
I don't know why you got into that much trouble with that, but that's correct. Yeah.
Okay. Yeah.
That's a surprising number of.
Okay.
Oh yeah. By the way, Eva, just so you know, like if there's 2 of the same size, like let's say like if you have a right triangle and then this side and this side is the same length, the diagonal is always if this is x, it's always x square root 2. Always.
Well,
yeah, that's
beforehand.
Pythagorean theorem. Wishing that doing before. I was wondering what you were doing. I thought you were that looks so complicated. I thought you were doing this side over here.
What?
I thought you were doing like, hold on a minute, like that was so complicated. I thought you were doing this one.
Oh no, I haven't gotten there yet. Let's see this times.
He provided proof, kind of same. You know what? I do appreciate it. Yeah, you did provide the proof that the diagonal is 9 square root 2.
Yeah, I showed my work.
Yeah, you should eat homework. Let's go. Sigma behavior.
81 times 2. This would be times 81 times 2.
Wait, did he even do that?
Square root.
Oh yeah, that's correct. Sorry, my bad. My brain went wonker.
1, 4, 5, 8. But if I do this, I can divide this by 2. 7, 2, 9. Can divide that by 3. Oops, did the wrong thing.
Reading chat. Someone said, why is this x just a dot? Is that? I don't think it's an American thing. I also learned it over here. Like there's like, I mean, later on there's like both x operations and dot operations, which are actually different. But like, I don't know, sometimes they use it interchangeably. It's kind of wonk. I personally don't really understand it myself. I know they're different. I know like x multiplication and dot multiplication is different. But yeah. Also, welcome to Leonardo as David. Pretty sure if someone from medieval times saw that image, they would accuse you of witchcraft. Yeah. Oh, you haven't seen the previous one on lesson 2. Oh, that was painful.
Oh yeah, I hated that one. So this is the root of 2, and 3 times 3 is 9. Huh? Wait, no.
Reading chat, someone, yes, I never use multiplication signs, just parentheses. You know what? That works. That works.
Oh, times 3, there we go, 27. Okay, so question mark is...
I wish you remembered the previous lesson.
I wish I did, yeah. Okay, now it... wait, I can't just do...
Yeah, reading chat, yes, it is indeed the squares and squares dealy. Oh, you did see that? Yes. It's a square inside square inside square. Reading chat, all these things, multiplication, division, yeah, it's all just addition in the end. In the end, everything comes down to 1 plus 1 equals 1. I mean 2.
In the end,
it doesn't even matter.
Okay, so this should be 3.
I swear I can't believe this. This is beautiful.
I probably am over complicating stuff. Okay, so okay, so if this is the shape, if I do this is 9, 2, this is 27, 2, this is 3. And this is 3, and this is 3. So this is 9. I'm so close. I'm almost there.
You're almost there. Almost.
Okay, so
You got this. You got this. I believe in you.
if I cut this and flip it over and place it here, it should be a rectangle. So
By the way, I hate how this is supposed to be the tutorial.
yeah. oh, right. This is
Oh dear.
9, 2 times 6.
Reading chat. Leonardo said I've been hanging out here during the stream. Just dipped out a few times because math makes me head hurt. It's okay, don't worry. And reading chat, you're literally abusing this guy, making him do math. Yeah, it is. It's mental abuse to humans. Yes.
Okay, the answer is 54 square root of 2. There you go.
Correct. That is correct.
Easy peasy.
Easy peasy.
And I
God.
didn't even sweat up.
How did you? I'm honestly amazed by how much you complicated this. like oh my. Hold on, let me do we have to do it? Yeah.
I'm not a lateral thinker.
Okay, do you want to know how to actually do this a simpler way?
Please.
Okay, so
Yes, please.
let's see. I'm gonna use the numbers that you gave earlier, so like 3, 3, and 3. And then so this is gonna be 9, and then this is gonna be 9. Okay, as I said, this is one is like the simpler one, but I appreciate your you trying to find the proof for this. So this is gonna be 9. Hold on, 9 square root 2. There you go. And then remember the first lesson.
Kinda.
You cut this in half, and then move it over here. Flip it, and it's just 6 times 9 square root 2.
I mean, I got there eventually.
Yeah, you got there eventually. But yeah, I appreciate it. It's a good effort though. Hey, you did decent. I like how you try to prove everything as well.
I found the hypotenuse.
Yeah. But yeah, also whatchamacall again? Trading chat, congratulations, basket should be sent where? I don't know, somewhere.
Just let me give you my IP real quick.
Also, by the way, I don't think you even need to find the hypotenuse to solve this normally.
No, you don't.
I don't think. Yeah, you don't. Yeah, I don't. Wait, did you even use the hypotenuse on your solution?
No, I didn't. I just
Oh,
to prove I could do it,
you just found the hypotenuse to flex on us.
Yeah, I'm just using all the knowledge I've learned today.
Yeah, you found the hypotenuse for the sake of finding the hypotenuse. My man heard Pythagoras theorem once and was absolutely mesmerized. Yeah. Send the basket to I don't know the hard drive or something. I don't know where do you live. I live in the floppy disk. But yeah, okay. Alright, now that's that. Now that's that. Okay, now is the real question. I swear, this one should be much easier. But let's see. Okay, boop. There you go. Ta-da! Find the volume for this, and if you want, you can also find the surface area. This one shouldn't be difficult. It should be pretty easy. This one.
It's a little house.
Yeah. I'm gonna assume that this is X, but I'm gonna let you're free to put any number there. I don't suggest putting 1 though, because that might mess some things up. I'm just gonna say that this is X.
Yeah, I was gonna say, what's your problem with not giving me numbers?
I like giving my students freedom.
Freedom of expression.
Yeah. If you can find the volume, and if you want, it's not mandatory, you can also find the surface area.
No, I'm not touching that. Let's see.
Okay, reading chat. Someone said, in the meantime, can you draw a house with an X inside without using multiple strokes? So I don't take off my thingy magic? Maybe? I don't really know. Something like this. Oh, you meant like, you meant I'm not allowed to do the same line twice, right? I don't really know. Let me try that actually while you do that. That's interesting. That's an interesting challenge. I like that. Oh, okay. Oh, that's difficult. How I can do that? Yeah. It should be possible. So if you do this, oh, that doesn't work. Okay, I'm gonna zoom in over here for a bit just to kind of brain this out. So if we have like,
once you zoom out, you're gonna be like, what the fuck are you doing?
Okay, I'm gonna quickly like draw the entire thing first. This is the house you mentioned. Like, is it like this? Is this correct for halting in the middle is also illegal. Oh, okay, so I need to make something like this. But I can crisscross, right? Am I allowed to crisscross? I think this is the shape I'm supposed to make. I think. Hopefully I get it right. Yeah, okay. So I'm not allowed to like do this. Got it. Let's see. I wonder. Okay, yeah, that doesn't work because I'm not allowed to like, do the line twice, right? Okay, so definitely start from the bottom then. So if I can do this. Oh wait, shit! I forgot I'm not allowed to halt. Do this. Is that correct? I think that's correct. I don't really know. I hope I did it correctly. Okay, there you go. Haha. Brain time. I played way too many escape rooms. That reminds me of that one portal escape room that we did. Oh my, what did you? You add another roof. I zoom out and there's another roof.
Yeah.
Yes, a second roof.
4 times 4 times 4. Plus 16.
But yeah, brain moment. Let's go.
80. There you go. That's my answer.
Okay, 80. I think I'm gonna like remove. I think you should put like maybe an M or something because like just having the cube there just makes things way. It doesn't work. You should probably add like for example a meter square or like meter cube or stuff like that because like not having like the cube notation here actually means the unit itself is also cube, like meter is getting cube, not exactly the number. If you don't put anything there, like that means you're cubing the number, but number is already cube.
There you go.
Yeah. Alright. Yeah. I'm not sure. Wait, oh, this is volume, right?
Yeah.
Okay, let me just double check that. What?
What did you ask for? Volume? Or...
Yeah, volume. I mean, you can also do like surface area if you want, but that's like that optional. But yeah, I actually quickly cross-check that. So 4 times 4 times 4, that's gonna be 64. Let me just write that down real quick. So that's like the volume of the square itself, the cube itself is 64, and then we also need that's gonna be 4 2. So that's like so we get the base of the prism, which is gonna be 2 times 2, that's gonna be 4, and then times 4 times 4, that's gonna be 16. 16 plus 64 plus 64 equals 80. Yep, that is correct.
Poggers.
80 power trail, take it or leave it. Oh god. Yeah. Yeah, that's correct. Okay, do you want to do the surface area as well? If not, I'm gonna just quickly do it, just for the funnies.
You can do it. I'll leave that to you.
Alright, you better pay attention. I'm gonna have a pop quiz at the end.
Oh no!
So yeah, so...
Exam.
Yeah. So if this is x, let's assume that this is x, and we want to find the formula for like the entire the surface area of this thing. We can actually just get like x times x, actually not times x, it's just x squared, and then there's 1 2 3 4 of the same size surface. So we can like wait, 1 2 3 4 5. Sorry, 5. So we can do 5, and then add this in parentheses. There you go. and then we want to do a plus, and then we want to just get the surface area of this thing. So first we want to get the surface area of these two triangles, so it's gonna be 2. And then if this is x, that means it's like half an x, so it's like half an x times half an x. So that's gonna be another parentheses x divided by 2 power 2 or squared, I guess. And then that's gonna be like this side and this side, and then finally this side, that's gonna be plus 2. This is what what me and probably Rodo meant by how surface area is annoying, because you just need to add up a lot of things. So this is gonna be 2 because there's 2 of the same sides, and then there's also gonna be this is x times, I'm gonna do a dot here, I guess, because like we would have an x. I should do the math x, but like and then finally we have the hypotenuse of this thing, which is gonna be x divided by 2 square root 2. There you go. And this is the formula for the surface area. Just replace x with any number and it should be the surface area of this thing. I think, as long as I, assuming I didn't mess up somewhere. But yeah, we're also waiting for no multiplication signs.
Wait for
no parentheses. Ooh, hell yeah. Only parentheses.
For the triangles. So
Yeah.
Okay, so the triangles is x.
This is triangle.
Yeah. So
because,
x. Wait, I can write. I forgot about that.
It's this and then this.
Wait, I need to shift in. Yeah, so it's x over 2 times x over 2. Shouldn't that be over 2 too?
No, because like that's gonna be only this triangle. If we if we're counting like this entire triangle,
Yeah. Okay. Yes.
Yeah.
I see. Okay, it makes sense. True. That'd be correct then.
All right. Okay. Boop. Okay, your turn. What's your third lesson?
Oh, that was it?
Yeah, that's pretty much it. That's pretty easy, right?
Oh yeah, I thought it was
definitely
be like
the easiest one.
I thought it was gonna be like a funky 4-dimension one with squares inside.
Oh god, I love how you say that.
I didn't actually prepare a third lesson.
Oh, I mean, we wanted to do probability, but like you kind of forgot about it.
Yeah, I thought I remembered, but I didn't.
Okay, shall I move on to the next lesson then? My next lesson, or do you want me to like do it?
I think you could do one more lesson. I like how we started saying like this won't take us more than an hour.
Yeah,
we're sitting almost 3 hours in.
Yeah, I know, right? Okay, I guess I'll do I'll do my last lesson. But yeah, okay. Now I love how earlier you said calculate the 4-dimensional volume of something, and I love how Rodo say calculate the surface area of a tesseract in x equals 4, because this is my next lesson. Let me like show you. Boop. This is my next lesson.
Okay, thank you everyone for coming. Next time.
Yeah. Let's see. Richard, probability is okay, easy marks, but okay. Yeah, probability is fun. I do enjoy probability personally, but like but this is the real deal. Level 4, 4D geometry. This is the one that's like very theoretical. That's like you won't really learn this in school. You just learn this in like and whatchamacallit again. If you study theoretical physics, you will learn this if you major in physics in school. But yeah, anyways, okay,
I
so
feel sick just looking at it.
Yeah, don't worry about it. Okay, by the way, okay, actually, before that, can you name that shape? Out of curiosity, hold on. Let me get that layer back. There, can you name the shape? The shape behind the thing. Do you know what that shape is?
An icosahedron.
No, that's a 3D shape.
I don't know 40 shapes. I didn't know they existed.
People talk about this a lot, but yeah. Rodo said probability is very easy once you realize everything has a 50% of either happening or not happening. Also, what's that?
This is a tesseract.
That is correct.
Hey, let's
this
go.
Yeah, this is actually how this is actually a projection of a tesseract. A projection is essentially how you draw a shape of a higher dimension in a 2D plane. Like, let's say you draw, like, let's say a cube. Let's draw a cube right here real quickly. And then do this. This is a shitty cube, but like I'm just proving, like, you know, bringing my point. This is, you know, this looks 3D, but it's actually just like a 2D shape. I mean, on a 2D plane. It's actually a projection of a 3D shape on a 2D plane. This, on the other hand, is a projection of a 4D shape on a 2D plane. And it's a tesseract. It's a projection of a tesseract. But yeah.
I'll just tell you that I read the answer in your chat, so.
I don't think. Wait, did anybody in chat even say the, like, you know, even say the answer? I mean, I guess like Rodo did say tesseract, but I never say this is actually a tesseract, you know.
No, I just guessed.
But yeah, okay, so let's actually get to the lesson. So this is where we combine the first lesson, the third lesson, like 2D and 3D shape. Okay, so I want to ask you first, how do you think you could find the formula for a tesseract, which is a 4D cube, a cube that's 4-dimensional?
Multiply.
It's the same length on all sides.
So side to the power of 4, right?
That is correct. That's actually how you get whatchamacallit, get the thingy. Whatchamacallit, get the, that's the formula for a tesseract. And then what about prism? Like, let's say you have any prism. How do you get the formula for that? I did hint about this in the 3D section.
Side times height over 4?
What?
No.
Try writing it down. Write it down.
Oh, right. Okay, so
Yeah.
I remember in the 3D it was base times height over 3, I think. So here.
That's a cone. That's for cone. That's for pyramids and cones.
What did you? Oh, you said prism.
Prism is different. Prism, not pyramid or cone. It's prism.
Yeah, no, I confirmed it. Prism, I don't know what a prism is. Prism is the triangle.
Prism is like a cylinder, for example. Yeah, or that.
Like that.
Yeah. Yep,
Yeah.
that's also a prism.
Okay.
Prism more like prison, yeah.
I don't know.
Someone in chat said, I suspected it was a tesseract, but it didn't look like that. What I would traditionally think of a tesseract. Yeah, I mean, in media, tesseract, media likes to media usually have really bad representation of like higher dimensions, but yeah, what the fuck is that? Okay, I'm gonna give you a hint. Try thinking of like try thinking of a square in 2D, a square in 3D, aka a cube, and then a square in 4D, aka a tesseract, or like a cube. Do you see and treat it as like maybe a rectangle? I think a rectangle is better actually. Yeah. Think of maybe a rectangle. Let's assume that there's a rectangle. So what's the formula of like a rectangle? Just a regular rectangle.
Times height.
Are you trying to draw like a 4D tesseract?
I wanted to, but I can't visualize it.
Don't worry, 3D creatures can't really visualize things like this. Kind of difficult.
Yeah.
We can only imagine the projection. Its projection, not really its actual shape. But yeah. So yeah, let's start with the rectangle. This maybe this rectangle. What do you think is the formula of this rectangle?
Side.
That's a square, not a
square.
rectangle. A rectangle. Mm-hmm. Okay.
Times the other side.
Now
Well,
I
height, I
want
guess,
you to yeah. Okay, and then I guess like the side change to base because technically it's the base. It's the one-dimensional base of the thingy.
Which is base too.
Okay, and yeah, exactly. Now what's the formula for the tesseract? Exactly. No, not the pie. No. Exactly. Now you see a pattern, right?
Oh, so it's just base times height for everything.
Exactly, and you can go and you can extend this to like higher dimensions. So like so for a rectangle, the formula is essentially the one-dimensional base times the height, and then for a cube, which is like I guess a prism, a three-dimensional prism, the formula is just the base times the height, and for a four-dimensional prism, it's just the base, and because it's four-dimensional, the base will be like three-dimensional because it's 4 dimensions. So this is gonna be the base, and then we multiply it by the height, whatever the height goes. It goes to another dimension. But yeah.
Okay, yeah, kind of makes sense.
Yep. Reading chat, the formula using variables is... yes, using emojis as variables, hell yeah. Yeah, so this is like the basis of that we're going to here. This extends to further dimensions. So yeah, this is actually also what we call like n squares, because like this is like a 1 square. And then this is a 2 square because this is a 2 square because it's 2-dimensional. This is a 3 square because it's 3-dimensional, and this is a 4 square if it's because it's 4-dimensional. Okay. Although correct me if I'm wrong, because I don't know if one like a line is 1-dimensional or like if it's 0. Correct me if I'm wrong, by the way. Theoretical physicists out there watching me. But yeah.
I was about to say I have no clue.
But yeah. Okay, that's actually the this is still the tutorial, by the way. That's the squares. I'm gonna like just hide the layer for that. So let's talk about the other shapes now. What do you think about a triangle? Try the same again. Try the same thing but with a triangle.
Okay.
So maybe like maybe you can make a regular triangle like this or something. And then you can also have its like its 3D counterpart, which is actually this. Let me show you. I guess I'll just use this. There you go. Yeah. Okay. You can start with trying to figure out the formula. There you go.
Okay. This is height times base ?
You forgot the first lesson.
Oh, divided by 2.
There you go. Triangle. It's a triangle. It's a square. It's a triangle. Oh dear. Reading chat, find out if I'm teaching you while looking at you in the eyes with Booba. Oh god.
Oh no.
Oh my, Hanan with Booba doesn't exist and he can't hurt you. Hanan with Booba. Okay, what about this one? I told you how to calculate a prism. Not a prism, a pyramid last time. A square-based pyramid. This one is just a triangle-based pyramid. Exactly, correct. Now, what about the 4-dimensional version?
Divided by 4.
Yep. Correct. So, what do you think is the n formula? The formula for an n pyramid. What do you think is the formula for an n pyramid?
HP times n.
Correct. Yeah, there you go. You get it. You're getting it. So yeah. If you want to ever get like maybe if you want to make, let's say, a 10-dimensional pyramid or something, you can just like replace the n with 10. That's gonna be like that's gonna be how you count the volume of the thing. But yeah.
Okay.
Yeah, I'm gonna get to the ball last because I'm not. The ball is like the most complicated shit. Yeah.
Wait, so we're actually touching balls?
What do you mean touching balls? Hey yo. Yeah, bro, don't call me the N formula. That sounds kind of feral. I mean, you do have a point. Oh god, but it's called a formula for like the N shape, because it's like the shape of like on the N dimension.
Let's say, kind of sounds like a slur.
Oh god, yeah, I know. Oh dear, god damn it, physics. Touching what now? Oh dear. But yeah, okay, next. Okay, now we're actually getting into visualizations. Let's actually use if we use how like space itself, our current world is 3-dimensional, but space-time is 4-dimensional because there's time as like the 4th dimension. Do you?
No.
No, because like how because okay, this one is really difficult to explain. Time technically is a dimension that we can, but it's like that we can technically perceive. So we can actually do something similar to try to visualize a 4-dimensional shape in a 3D space. So I'm gonna give you a picture of a hypercube. This, okay. As weird as this looks, this is a representation of a hypercube. Can you tell me why?
Because it replicates itself infinite times.
Okay, I'm gonna a tesseract, I guess. This is a tesseract. This is also known as a Rubik's Cube, as Rodo said. Oh god. Yeah. This is actually like a way to draw a tesseract. That's comprehensible to the human brain. Because here's the thing, here's how you actually read this. So this to this, it's like 3, and then this to this. Hold on, oopsies. This to this is 3, and then this to this is 3, right? And then there's 1, 2, 3, because it goes 3 blocks into the 4th dimension. 3 units into the 4th dimension. So it's like a 3 by 3 by 3 cube. Do you get it now?
Yeah, okay.
Yeah, essentially this is like an easier to comprehend visual representation of a tesseract, a 4-dimensional cube. But yeah. So, so this is a a tesseract, or you can call it a 4-dimensional cube. A 4-dimensional cube. That's what you can just call it that if you don't know the name for it. But yeah. Okay, I'm gonna give you another picture, and I want you to tell me what shape it is. Okay, this one. What is this?
It's a 4-dimensional sphere.
No, it's not a sphere. Not a 4-dimensional sphere. Think of it from a I don't know how to actually describe it, but just any other whatchamacallit again? Guesses?
Hypersphere?
No, it's not a hypersphere. A hypersphere is a 4-dimensional sphere.
So, ain't this a 4-dimensional sphere?
No, it's not.
Is it not? Is it just 3 spheres, 3 balls?
Okay. Shall I tell you?
Yes, please.
Okay, I'm gonna tell you to make it you understand this. Okay, let's see. Let's say we have a plane over here. So this is how we visualize the thing. Let's say we have a plane, like a 2-dimensional plane, and we also have a cube here. Let me get the picture. Let me get a nice picture of a box, a cube, just to make it look nicer. Hold on, where's the cube? Okay, here's a picture of a cube, and then let's get another layer and put a cube over here. If I can do that. There we go. Okay, so let me just do this. Okay, so we get a cube and let me make it that smaller, and we get a cube and a plane. So what do you think will happen? Let's say there's like a 2-dimensional creature on this plane over here. So let's give it like a head, and then let's say this is a 2-dimensional creature. They can they can move along the 2-dimensional plane, but they can't really see or move through the 3-dimensional plane. What do you think will happen if I push this cube through their world? What do you think they will see?
A square.
Exactly. Now, and does the square change when assuming I go straight, will the square change? Let's say what they see is hold on, let me quickly see. Let's say I have oh god, I forgot to do this. Let's say I have let's say this is what the square looks like on the 2D plane. This is the 2D plane, and this is the square when I push it through it. Does the square change in any way when I push it through, assuming it's straight down? So that's a plane coming from the second cube, no. But yeah, what do you think? How do you think it's gonna like go through?
It just goes straight through, like no changes.
Yeah, exactly. Like, you know, it's gonna suddenly appear and then suddenly disappear. That's how it, like, you know, assuming you're not putting it in at an angle as well. But yeah. Now, let me give you a ball. If oopsies, I want this ball to be a stroke. So if it's a sphere or a ball on the other hand, and I push it through the plane, what do you think it's gonna look like?
Small circle, then a big circle, then a small circle again.
Exactly. And that is like, you know, a 3 cube in 2D plane. So, going back to the thingy over here, what shape is this?
Circle?
It doesn't change, does it? It's not. It's definitely not the 4-dimensional sphere because, as you said earlier, if you push a ball through a plane, it goes from like a tiny circle to a big circle to a tiny circle, right?
It's a 4-dimensional circle.
No.
Oh, a cylinder.
Yeah, there you go. Finally, that took so long. This is a 4-dimensional cylinder. This is how a 4-dimensional cylinder looks like.
Just the sadness in your voice when you said no.
It's a cylinder. God damn it! It's a 4-dimensional cylinder. If it's a 4-dimensional sphere, that has a base of like that has a circle base. It will start off like as a dot, and then it's gonna expand to its full size, and then it's gonna reduce to a dot again. But yeah, I'm almost disappointed. But yeah,
It was heartbreaking.
Top 10 anime betrayals. So yeah, this is a 4-dimensional cylinder, essentially.
Okay.
Yeah, or you can also say it's like a 4-dimensional prism with a spherical base. Because, you know, like same with like the hypercube or like the 4-dimensional cube, it's essentially just like a square-based prism that goes into like, or not a cube-based prism technically because it's 3-dimensional, because the base is 3-dimensional. A prism with a 3-dimensional base that goes 3 into the 4th dimension. This one may like show you again, just like, you know, just so we get it. There you go. This thing, it's like it has a 3-dimensional base and it goes 3 into the 4th dimension. It doesn't change. So it's like it's a what am I call it again? 4-dimensional cube, a tesseract, I guess. But yeah, okay. Now, what about this one? Let me like get the picture in.
That's an empty space. Okay, that's a.
Think of it from the perspective of a 4-dimensional creature. Or use the layer thingy magic that I taught you.
Pyramid? Something?
Yep. It's a 4-dimensional pyramid with a cube base. Exactly. Oh yeah.
Oh.
Now, can you give me the formula? Can you still remember the formula to calculate this? It doesn't have. I mean, this picture is like just approximate, but like, you know, you should know.
That was base times height over 4. Yeah.
Let me see. Let me just quickly move your layer up because it's like up there. Yeah, and yeah, it is correct. So like, essentially the base, because the base is not a plane, the base is a cube. We find the area of the cube, which is, well, like, you know, 3 times 3 times 3 times 3, which is gonna be 72, and then we multiply it by 3, which is the height of the thing. Oh god, and then we divide it by 4 because it's 4 dimensions. But yeah, it's actually not gonna, like, you know, whatchamacallit again? It's actually not gonna be accurate if you're just using this because of how, you know, because of how I drew it. The last one is just a cube, so I don't think it's gonna be exact. What is it gonna be actually? Like this is 27, and then this is gonna be like 1, 2, 3, 4, 8, and then this is gonna be 1. If we add that together, that's gonna be let me see, 27. I can't bother like math things, so like 36, and then but if you use the formula, it's actually gonna be 27 times 3 divided by 4, which is gonna be 27 times 3 equals divided by 4 equals 20.25, which is actually like pretty different. God damn. 24.25. But you know, like keep in mind that this is supposed to like go smoothly. Like if you try to draw it, it'll probably look something like this or something. I don't actually know how to actually like, you know, putting more lines in it just makes it look a lot more complicated. So I don't like to do that when I'm teaching 4 dimensions. But yeah, this is essentially how it is. You know, this is actually how a lot of people you know, like try to show what 4-dimensional shapes look like, and it does not make sense at all. I think it's much easier to make sense of it if you do it like this. So like, you know, 1, 2, 3, 1, 2, 3, and then 3 to the 4th dimension.
It's easier on the brain, yeah.
Yeah. But yeah, okay. And yeah, okay. My lesson on this one is actually mostly just like having you find the formula for like I'm not gonna say n again. I'm gonna say like, you know, hyperprisms and hyperpyramids, which you actually already did. Okay, do you still remember that?
Barely.
Yeah. Okay. So like, if you want to find like any prism, a hyperprism, so like a prism that's like in any dimension, the formula is gonna be base. I drew in a hidden layer again. It's gonna be base times height. So height into the 4th dimension. And for like for pyramids, it's gonna be base, height, and then n, where n is like the number of dimension you're in. So if it's like 2 dimensions, it's gonna be 2. If it's 3 dimensions, it's gonna be 3. And if it's 4 dimensions, it's gonna be 4, and so on and so forth. But yeah, So now, okay, so now honestly, that's all the lessons for this one. It's actually pretty easy. Like surprisingly, the easiest one out of all of it. Okay, so now, do you want to know what you know, a hypersphere's formula is?
Sure.
Can you try coming up with first? Actually, try comparing the formula for like for a circle and for a ball.
Circle is 2 times r times pi. Finally, we use pi.
Finally, we use pi. Yeah.
For a ball,
Let me actually like quickly get the hypersphere formula, because I swear the hyperspheres are painful, or hyperballs. It depends on like which one like you're calculating for.
Don't think I've ever calculated the volume of a ball.
I mean, it's like, it's a niche thing. Like they do teach you in high school, but it's kind of niche.
Times r times pi. Let's hear it.
Oh god. No, it's actually like let me write it down. It's actually 4. Wait, hold on. I think I got it wrong. No, that's like the surface volume. What the fuck is the? Yeah, the 4 divided by 3. Let me actually double check that. And I'm second guessing myself now. Oh, it is correct. Apparently, I thought first, I don't know why, but for a second I thought it was like the surface area, the formula for the surface area. So for a sphere, it's like what can I write there? Okay, there you go. It's 4 divided by 3, and then pi. Oh god. Pi, and then r, and then 3. There you go. That's the volume of a sphere or a ball. I mean, technically a sphere is hollow and a ball is like filled, so technically it should be a ball. Speaking like the mathematical terms, I guess. But yeah. So as you can see, it's kind of whack, right? Like you don't really see any patterns here.
Yep.
That's because the formula for an n sphere, or not a sphere, an n ball is actually like a hyperball. It's actually this. just looking at this normally, it's like, you know, okay, that kind of makes sense. But then you see, oh god, that's a gamma function. Oh no, that's a gamma function. Okay. But yes, this is the reason why I didn't explain circles. Also in the previous lessons. Circles are just complicated. Circles are weird. I don't like circles. Yeah, circles are like that. Is that one guy in the party that is just a weirdo, you know?
That's why I play Minecraft.
Yeah, reject circles. But yeah, if anybody wants to try explaining, like, you know, this thing specifically, the gamma function, please do. But like, you know, I don't want to try to explain this shit.
That's for extra credit in your final exam.
Yeah, I doubt your teacher even knows. Like, try asking your math teacher. Do they know what the gamma function is? Oh dear.
To be fair. Oh no.
I mean, I know I don't. I don't understand what the hell a gamma function is.
That's the first time I've heard it.
Okay, let me. Okay, can I like get an image of it, because this is so stupid. Gamma functions are so stupid. Boop,
oh no.
Boop. If you put it on a graph, it shows this thing. Oh dear.
Give me a sec. That's
Okay.
my phone.
That's a nice ringtone. Okay, but yeah, this is a gamma function. Okay, oh god, this looks weird. Let me like make a new layer, and then let's fill this up with like white. Let's see. Boop, there we go. And let me like quickly do this, and then quickly do this. Okay, this is it. This is a gamma function. I'm not gonna try to explain it. I don't even know what this is. How do I explain this? But it's part of the circle formulas. It actually makes me kinda impressed by you know how those people who invented math or something, those people who invented the formula for circles, balls, and whatever an end sphere is. But yeah, and yeah, I'm gonna wait for like Effa to like be done with the call, and that actually would be like the like whatchamacall again, the where we wrap the thingy magic. Whatchamacall again? Where we wrap the, oh god, someone just added me to my thing yet? That's whack. December 2022. Who the hell is this? I was checking Discord for a second. 2022? Who the hell is this? And I need to check this later. But yeah, it's whack. What do you guys think though? Hopefully all of you learned something, by the way, today. Hopefully all of you learned something. I sure hope Effa actually learned some stuff, but it seems like Effa kind of forgot a lot of the things from the previous lessons. And you know, I'm actually surprised by how long this took. Like 3 hours, 3+ hours. Goddamn! I didn't expect to teach math for like 3+ hours. I thought this is gonna be like, you know, gonna be a short stream, and then we're gonna do like, you know, start drawing some funky stuff at the end by the end of the stream. But yeah, So yeah, that is geometry in 2 dimensions up to 4 dimensions. No, not that I can do 1 dimension. I don't think you can even do 1-dimensional geometry. It's kind of wank. 1-dimensional geometry is really wank. But yeah, there's also a lot of other like shapes you can make in 4 dimensions, kind of like how you can make, like, you know, combine different shapes in 3 dimensions earlier to make a new shape in 3 dimensions, which is just splicing the basic shapes you can make, which is just the prism and the pyramid. But I'm not gonna get into that because it gets exponentially more complicated, because, you know, the higher you go in dimensions, the more sides you have. And the more sides you have means the more, well, you know, more shapes you can make. So yeah, you can make some really wonky shapes.
Beep.
Hey, welcome back. How was the call?
Sorry. My friend wants me to lend him my laptop.
Alright.
And I told him, hey, I'm gonna take at least half an hour, so if you can wait, that's fine.
Yeah, let's go. Yeah, I was just like, I was just summarizing the entire lesson, and we're actually mostly done here. What do you think?
It was more entertaining than I thought it'd be.
I'm surprised you like managed to like get into like the 4-dimensional one without too much trouble, which is neat.
So, you know what? I saw a video about somebody explaining that, where they had like a sphere, and they said like, let's simulate me pushing this sphere from one dimension to another one, and they explained it with the circles. And then like visually the sphere got big and then it got small again until it disappeared. So I kind of had my head wrapped around that beforehand. So yeah, it was less mind straining.
Yeah, it's essentially just like translating that into like a higher dimension. The same thing goes for like up into like a 5th dimension, 6th dimension, shit like that. Like like let me see, like let me remove the gamma function because ew, what is that? What the fuck is a gamma function?
I
ew.
saw it. I do not understand it.
Yeah. Like this actually extends into like more dimensions. For example, if I take the 4-dimensional cube, why is it like over there? Hold on. If I take the 3-dimensional cube, oh no, Carlos, whatever happened to you? And then if I like, wait, why can I even copy paste here? I don't think I can copy paste, which kind of sucks. Yeah, I can't copy paste things, which is kind of weird. But I guess I can do something like this. I can duplicate the layer. We can do something like this, and we can do something like this. This is a 3 by 3 by 3 by 3 by 3 5-dimensional cube. Because it gets deeper, it gets much deeper, because what?
Yeah, I'm guessing if you extrude it like 2 more behind, it'd be a 6-dimensional one. Yeah.
Yep. Yeah, this one is essentially, this is the base. This is like the 4-dimensional base of the 5-dimensional cube, I guess. And then this is like the height of the into the 5th dimension.
Oh no.
Yeah, I know.
Like
don't worry, you don't need to worry about that. I'm just talking about like the bullshit stuff now. Like this is I don't know when I think you only learn this in theoretical physics. I don't know.
Oh no.
But yeah.
I'm so glad I don't have to study that.
Some people enjoy it.
Oh yeah, definitely.
I personally enjoy some parts of it, but like not all of it. Oh god, I can't imagine doing like I don't want to do gamma functions, What the fuck is a gamma function?
Not for me. Not today, Satan.
But yeah, that should be it. Thanks for the stream, I guess.
Thank you for teaching maths, and yeah.
Same here. Went on the entire roller coaster of emotions.
Yeah.
And thank you everyone who tuned into the stream as well. To this really wonky stream. Why did I even do this stream? This is like a really experimental stream, but also kind of like a funny idea that me and Eva kind of thought about. But yeah, I'll bring it up here. So thanks for coming, everyone, I guess. And yeah, I'll be back on Tuesday with. Actually, no. Maybe. Actually, yeah. I think I'm gonna be back on Tuesday with like just chatting stream. Maybe a short one, maybe a long one. I don't know, but because it's the end of the month, I don't know when my interest is gonna die. So, yeah. And then game wise, I'm gonna be back on like on December, Christmas. Oh no. But yeah, okay. I'm out. Bye bye, everyone. Have a nice day.
Bye.
I am out and in the stream.